Sir, actually, I also have a question regarding this examination. Can I ask?
Sure, go ahead.
Sir, is it necessary to attempt all the sections, or can I go for only one section because I have scored well in rest of them?
Okay, one section in the sense like particular week or some concepts or something like that, is it?
No. In examination, like only maths I can attend, or I have to attend all of them and pass in all of them. Then only best of two will be considered.
I think it will be done individually.
Okay, so means I can attempt only. I can focus on attempting very good in one
Well,
of the subjects.
okay, so maybe I'm not sure of this then.
What you said, sir?
I'm not sure of this. I'm not sure of this.
Okay, no
Yeah,
problem.
yeah.
Okay.
Maybe you can write to the support and ask this.
They said that they will consider individual scores.
Then it's okay then. Then it's good, right?
Okay, sir. Yeah, okay. But I will be trying to get good scores in mathematics
Yeah, sure.
on all the subjects that will increase my overall score.
Exactly, yeah.
Yeah.
That should be
Okay,
okay.
no problem, sir.
Yeah.
So we can start, I think.
We can wait for another.
MA1001, sir, are you saying something?
So maybe that's a mistake or something. Okay, so you can see my screen.
Yeah.
Yes, sir, it's visible.
Yes, sir.
So you can just go through this once, or maybe I can tell you what these are. So till then, everybody of you can join. So you see, this is what roughly I'm telling. Okay. So now you see in week 1, the syllabus, it will cover like 30 to 35%, which is a big number, right? So what you have to really give emphasis to is this: what are the type of relations? Okay. And then questions on sets theory. And I think you will be knowing now, which involves this Venn diagram and set comprehension type problems, right? So those kind of
Yes, sir,
questions are really important.
this part only I want to discuss today.
Okay, so then it's good, right? We'll discuss here.
Yeah, yes, sir.
More here. All right. And also the type of relations. Now you might be thinking, what about functions? So functions, I would say specifically, you won't be asked any questions as such from week 1.
Week 1 and week 4 is very important.
Yeah, that you can figure it out, right? Almost 60%
week 1 and
of
week
your
4.
Yeah. Almost, you can say 70% of it are from these like week 1 and week 4, right? So yes, so what you can see is, so you see here in week 1, you will see that functions is something which I haven't mentioned, and that is something true, that we haven't asked you directly questions on functions, but you will find this concepts of functions being asked in your week 4. We might ask you a graph, then we might tell you, okay, is this one functions? So that's a concept of week 1, right? So that's why I did not mention it here, because what you have did here in week 1 is a very crude sense, like just the concept you have learned, like what is functions, right? So we'll just give emphasis to what is important to our exam for today's session, okay? And then we can keep some, at the end, we can take some doubts, okay? So we can do that. So week 2, as I have mentioned, you have to cover all concepts. It's not a concepts at all. It's just basically those formulas you have to memorize, right? And you would find it's very easy, right? So all you have to give emphasis to is like, what is a straight line and what are the conditions for these parallel and perpendicular lines, right? Then distance between the point and a line, right? Then distance between two lines. These concepts, you can just by heart or go through those formulas. Those are like very small formulas. Just practice them. Do 1-2 problems, done. Week 2 is nothing more. Okay. Similarly, when you go to week 3, again, all concepts are important. Basically, there are no much concepts in these weeks, right? So that's why I have written all concepts. All you have to do is, how do you find roots, right? So that is something important. Then how do you write the quadratic equation in invertic forms? Then how do you do the graphing of that quadratic equations? That becomes very important. And in week 4, see, I have just written graphing of polynomials. So what I essentially mean to say is, if you can draw the graphs of a polynomial, you are done. You can answer any of the questions. So what are the possible questions we can ask in graph 4? So as you have gone through the contents, you would find that there is a questions whether this function is increasing in this interval, decreasing in this interval, right? Is this
Sir, your voice is low.
My voice is low?
Yes, sir.
Is it better now?
It is very loud, something wrong at your end. I think so.
Yes,
Please
sir.
check
You are
at your end.
clearly audible.
Very
Yes,
loud
sir.
and clear.
Yes, sir. Yes, sir.
Please correct
I'm
yourself.
finding
Yes, sir.
it's okay. Yes, sir.
It's okay.
I'm finding loud and clear, to be honest.
Yes.
All right, so just
It's
see
crystal
to it
clear.
whether just see to it your network is in proper. So all right, so I was talking about week 4. So week 4, as you can see, a maximum questions, right? You might see the question will be of 2 or 3 questions, but you would see it will be have a more weightage, right? So it considers, then you can account that as more weightage in that sense, right? So you see in graphings, now this is week 4. I mean, week 4 is such that you can actually intermix all the concepts, right? That's why week 4 becomes very important. And then what else you can do with the polynomial? So that's what, right? You can just draw the graph. What else we can ask you? It's like number of turning points, right? Is this one functions in this interval? Is it increasing, decreasing, right? This is all we can ask you, right? So once you
Yes,
can
sir.
figure out how to draw the graph, then it's done. And I
Sir,
hope you know.
also there is a SSC for polynomials also. Means, are we going to discuss that also?
Okay, so I forgot to tell you, SSC, you will see here, I have written it in week 3. So week 3 means something involving SSC with quadratic. So you would have
Yes.
seen it in your mock and elsewhere too, that this question has been asked, right? You remember that carpenter problem?
Yes.
Yes. So it will give a
Basically,
pattern to this.
values are given and we have to find the value
Yeah.
of k. It is from
Right.
polynomials.
Yeah. So in case you have all forgotten, like how to find this SSC, no problem. We can just discuss one problem, but I won't be doing with the quadratic one because that we can do something with higher degree, let's say a 5-degree polynomial, right? So if you can do 5-degree polynomial, then you can certainly do 2-degree polynomials, right?
Yes.
So the concept is very same. So we can do something like that. So no worries. But so this is this is the whole structure. Okay. So I don't think so. You should have any doubt here. Like
Sir,
what is
but
the
SSC is in week 2, right? Means after equation of
That's what.
lines.
Right. So why I have mentioned here is your f of x could be anything when you're doing your SSC, right?
Yes.
So it can be a quadratic, it can be a polynomial, it can be exponential, logarithmic, anything.
Mm-hmm.
Right? So where to put in then? SSC, though it is in week 2, but you would find that your f of x, what you write, right? Like
It
in
could
your
be
formula,
any degree of polynomial.
any
So,
degree of polynomial. So I wanted to give emphasis that it is 2-degree polynomial. That is why I have written it here in week 3. Okay.
okay. Got it, sir.
Yeah. So that's how it is. So this is all that we will be discussing today. So what I'll be doing here is I have prepared some questions. Okay. So I'll be discussing those questions and the concept simultaneously. Okay. So
Okay.
that's what we'll do, and we'll give more emphasis to what is coming in your exams. Okay. Because
Okay,
there are
sir.
a lot we can discuss, and we can actually go on for a day, which is something not essential for examination point of view. So what we'll do
Yes.
is just what is coming, what is very important for your examination point of view, that we will do, and rest all I can always tell you hint like where to focus, where and what not, right? So
Okay, sir.
that is something we can do, right? So I hope
Okay.
that is okay.
Yes, sir.
All of you are with me?
Yes, sir.
Yes, sir. Yeah.
Yes, sir.
Yes, sir.
Let's
Yes,
go
sir.
to week 1 and let's go to these kind of questions. Okay. And so as I told you, with question I'll be discussing concepts. So this way I think we can do it faster, and like we can always recollect things, because I believe that you have already gone through the things and you have enough time to practice, so you have already gone. Okay. So now let's say this is your particular question now, and
Answer is 6, sir.
answer is
6.
6. Great.
6.
Great. So already. And do any of you are struggling how to get this?
No, sir.
Any of you?
Reflexive, symmetric, and transitive.
No, sir.
So you don't want me to discuss this question?
Yeah. Please explain. Please explain.
Yes.
Sir, please explain.
Please explain.
So here, since it is equivalence relation, so when you get a questions like this, what you have to give emphasis to is, first of all, what is your set A, and then what is this relation with? It is in itself, right? A cross A, right? And it says it is an equivalence relation, and then you have to find the minimum number of elements, right? So when do you say it is an equivalence relations? So you know that a relation is equivalence relation, right? Maybe When do you say equivalence relation? When it is symmetric,
reflexive, transitive.
reflexive,
Transitive.
and transitive. So a relation is a equivalence relation if it is symmetric, if it is reflexive, and if it is transitive. So it has to fulfill all these three conditions. Okay. So that is how we find out this, right? So now let's go with the sets which is given. So now a set A is given and it contains how many elements? 6 elements. Okay. So first I have to build my transitive relations, right? So I remember not transitive. First I'll go with reflexive, right? So why do I choose first reflexive?
Because if a relation is reflexive, then it is a more probability to be symmetric and transitive.
Yeah, that is one approach. Definitely, that is right. So yes. So first, I would see since in the question, what is it asking is what is the minimum number of elements that R must contain, right? So what is the minimum number of elements that is something we'll have to figure out. So since we are dealing with minimum number, so could you tell me what all elements does your reflexive relation contains? So when I have to list my R,
10.
so if you are with me, and then you would have known that a reflexive relation must contain diagonal elements, and then it can have any other elements, right?
Yes, sir.
In simple way, a reflexive relations can have all diagonal elements and all other elements as well. But identity relations will only have diagonal elements.
Diagonal
Right?
elements.
Right? So that is something we know, right? So what does if that is the case, and I have to make sure this relation is reflexive, then what is the minimum number of elements that I must have for it to be a reflexive relations? I must have 6 elements. So which are those? 10, 10, 20, 20, 30, 30, then 40, 40, then
50,
I can have
50.
50, 50, and then I can have 60, 60, right? So this is something I can have, right? So now this is my relation, isn't it? Now this is a relation and which says this is a reflexive relation. So as I was telling you, a reflexive relation is the one which must contain all the diagonal elements. Apart from the diagonal elements, it may or may not have any other elements, right? So now I can put some other elements also, but what do we have to find out? Minimum number, right? Minimum number in R. So when do we get minimum number? I'll just list them, the minimum criteria for it to be a reflexive relation, right? So minimum criteria means it must contain the diagonal elements, right? So now this is okay. Now if I got this, then let's check whether these elements are symmetric, reflexive, symmetric or transitive or not, right? So this is what we will check. And we'll see if we have to add some other elements to make them into a symmetric or transitive, right? That is something we can check for. So first of all, look at this. So we are checking for this symmetric relation. So when do we say a relation is symmetric relations? When A comma B belongs
If there is
to R.
A comma B, then B comma A also belongs to R.
If
Then
B
B
comma
comma
A
A
also
should
belongs
belongs to R. Right? So sorry, this notation is wrong. In this relation R. Okay. So now tell me what is A comma B in this? What is A and what is B?
10
Sir,
or 10.
And
10.
what is B? 10.
10.
So now I have to find out where is my B comma A. So B comma A is nothing but
10
it's the
comma
same,
10.
10 comma
again the
10.
same
Yes,
element, B comma A. So you see this element in itself is what? Symmetric,
Metric.
right?
Symmetric.
So
Yes.
that is something we got it. Now we have this, that this itself is symmetric. So likewise, even this itself will be symmetric. Same goes with this, this, and this. So I found that when I just listed the reflexive, minimum number of reflexive, minimum number of, so basically what I'm doing here is I'm listing out the relation which contains the minimum number, right? So I first listed what number
Sir, can we check with it itself?
Sorry.
So here you say A comma B is equal to B comma A. So, but
Yeah.
you are checking with itself only, not with the other.
You will have to check with itself. You can do that. Certainly you can do that. Okay.
Okay, sir.
Yeah. So that is okay. So we found what is our reflexive. We made sure that this relation is reflexive. Then we We found that this is symmetric. Now let's check with the transitivity. Now what does transitivity says? If A comma B belongs to R and B comma C belongs to
C belongs
R,
to R, then AC
then
belongs to R.
And A comma C must also belongs to R.
and A comma C must also belongs to R, right? So
But
this
if A comma B belongs to
Hmm.
R and there is no B comma C, then we will not check for A comma C and we will declare it as transitive, right?
right, perfectly right. So that is also that we have to pay attention to. If this is not there, then in itself it is transitive. You don't have to check for that, and then you can say that yes, it is transitive in itself. All right. So now you see this. First, let's check A comma B. So we'll
can
start
you
with our
repeat
first
again?
element.
Can you repeat again?
So we'll start with our first element. This is our A and this is our B, right? So now AB belongs to R, then I have to make sure that B comma C should belongs to R. So what is B then? B is 10. So I'll have to check with all that elements starting with 10. So this starts with 10. Okay. Is there any other elements which starts with 10? Is there any
No,
other
sir.
element? There is no
No.
element. So I will just check with the same element. So here A comma B is 10 comma 10. What is B? Then this is B comma C, right? Because I'm checking with the same pair. I mean with the same element, right? So
Yes,
you see
sir.
that C is also 10, right? Now if C is also 10, then what do you see? What is then I have to make sure that A comma C belongs to R. So what is A? 10, and what is C? 10. So does 10 comma 10 belongs to this relation? The answer is yes, the same element. So the same elements is satisfying all these, right? So therefore I can say that this element is transitive, right? So what about the other thing? Fulfill the conditions of transitivity. You have any doubt?
Yes, sir. Can we say that diagonal elements are means diagonal elements or
Yes.
diagonal relations
Yes.
are just means equivalence relation because every time it will be happening the same.
Correct. You can say this, but just simply to touch upon the concept, I was telling you this. But you
And
can
now
certainly
if we say
analyze it.
that we have 10 comma 10 and 10 comma 20,
Hmm.
then we have to check for means A is 10 and B is
20, then you will have to check likewise for others. Like
okay.
then you will have to check all that elements starting with 20, right?
Okay.
Okay.
Sir, if we have A comma B but not B comma C, then we can also say that it's transitive.
Then also you can say
Yes.
that it is transitive.
Okay, sir,
Okay.
thank
Okay. So
Okay,
now,
sir, what is diagonal elements?
oh yeah, sorry. So thanks for asking this. I was hoping somebody should ask this because I took it in a
I was,
very short session. So no
yeah,
problem.
okay,
So what do
please.
I mean is it's just a simple notation or a simple word of mouth. You can say that we use it like when we are teaching this. So diagonal elements are nothing but these kind of elements. You see the identical same elements.
Same elements are
So
there.
so it's basically they are mapped to itself.
Sir, what is the answer to this
Okay.
question? Minimum
Thank
number of elements is 6.
So yeah, so the answer is 6 for this.
Okay, sir.
So if I tell you,
sir, sorry to interrupt you. Sir, 10 comma 10 is diagonal or the whole set 10 comma 10, 20 comma 20 or 30 comma 30?
each
whole
element,
set.
now I can call this as diagonal element, this also
Okay.
as diagonal element. So what I was telling you is, I was telling you for a reflexive, for a relation to be a reflexive, it must contain all diagonal elements. So this is one diagonal element, this is also one diagonal element, this is also. So you have individually 6 diagonal elements, but for it to be a reflexive, it must contain all diagonal elements. Okay, that is the minimum condition. After this you can have any number of elements, but since in the question it is asking minimum number, right? So we can stick on to saying that yes, the minimum number means I must have diagonal elements. So how many diagonal elements I can create? So 10 will be mapping to itself, 20 will be mapping to itself, 30 will be mapping to itself. Likewise, I'll have 6 diagonal elements, right?
So I mean, I can just count the numbers of in the
just
A.
count the number of this. So for this particular, this kind of question, what you have to do is just count the number of elements, and what is been asked, okay, it has to fulfill this equivalence relation, and what is the minimum number that I have to, so this is asking for a minimum number, so all I have to do is just count the number of diagonal elements. So how many I can have? 6. So the answer is 6. Done. Okay, but again, why I was explaining you all this thing is whether a diagonal element can be a symmetric relation, whether a diagonal elements can be a transitive relation. So we just figured out that all diagonal elements are symmetric as well as transitive, right? Or you can say even this way, each diagonal elements are symmetric and transitive. Am I clear on this? So if I
Yes,
so if
sir.
I have to just say this, now if my, let's say R1 contains just this element, 10 comma 10, okay, just it contains this element. So is this symmetric relation? Yes.
Yes,
Yes.
sir.
Yes.
Is this a transitive
Yes.
relation?
Yes.
But is this a
Yes.
reflexive relation?
Yes.
Somebody say me yes.
Yes.
No, it is not reflexive.
No, sir, it's not reflexive because
It is
all the
not
elements are
reflexive.
not diagonal.
I have
It's a
repeated
condition for
multiple
it to be
times.
reflexive.
It must contain
But-
all diagonal elements. Clear?
But
And here
Sir,
only
but
10
one-
comma 10 is present.
Yes. In this relation, I'm just giving one element. So first of all, this is not reflexive if I'm just giving one diagonal element, because this relation is mapped from A cross A, isn't it? So I must
Yep.
contain all those elements of my
Okay. Okay.
I must contain all diagonal elements. So certainly this is not reflexive. So can I say it is equivalence in this case? No.
Nope.
No, sir.
Right?
No, sir.
Okay.
So
So
it
now wherever
must
you
contain
get
all diagonal elements.
Sir, I'm
Yes.
not getting it. Please explain it again.
reflex, what you didn't get?
This 10 comma 10, why it's not reflexive?
Okay. So I'll tell you, just keep it in your mind. A relation is a reflexive relation if and only if it contains all diagonal elements, first point. And second point is it may or may not have any other elements. Clear? Keep
Sir,
this in
but-
your mind.
But it has one element, 10 comma.
But I'm
10.
telling all diagonal elements.
Okay. It must
Definition says what?
contain 20, 30, 40.
Okay, sir, I got it now. I
Must
got it now.
contain all diagonal elements. It does not
Excuse me,
contain
sir.
all diagonal elements. Yes.
Excuse me, sir.
Yes.
So while writing this answer, like it is saying what is the minimum number of element that are contained. So we are going to write 6, or we have to write this 10 comma 10, 20 comma 20.
No. You
30.
just have to tell the cardinality of this. So
Right.
that will
Okay. Okay.
okay. So I hope this is okay.
Sir, what
Sir,
if it was written that the maximum number of elements of that R must contain? So it will be 2 to the power n, right?
R must contain how many elements? Yeah, that you can say that.
We can also say that.
2 to the power of n, or like R cross R, A cross A. So it's basically A cross A. That is the number of elements that R will contain, right? So that's going to be 6 times 6. That is 36. So you'll have 36 elements.
Okay. Okay.
Okay. So
Sir,
now this is okay.
Sir, I have a doubt here.
Yes, please.
Sir, for one relation to state it as a equivalence. So in that equivalence, we have to see for symmetric, reflexive, and transitive. But my doubt is exactly suppose if we for example, we can take this. So if set A is given, and if they are asking for symmetric relation, but they are just asking is this relation is a symmetric, but they have given only one element, for example 10 by 10. So can we state it as a symmetric relation, or less it should contain all the elements? I mean,
No.
symmetric for all the elements.
Okay. So for it to be reflexive, it must contain all diagonal elements. That is certainly sure case, right? Because that is the definition of reflexive, right? But for symmetric, you need not have symmetric. What is the definition? You can just go with the individual definition. Symmetric relation is if A comma B belongs to R, then B comma A should belongs to R, right? So now you see this, if I have to have this element 1 comma 2, let's say this R2 is mapped from A cross A. Now it contains 10 comma 10. So you are convinced that this is symmetric? You are convinced is this symmetric?
Yes, sir.
Right?
Yes.
So this is symmetric, but can I say this is symmetric?
No, sir.
No.
No,
Because
sir.
it says if this is A comma B, then I must have what? B comma A. Okay.
Sir, will it apply for transitive too, or less for transitive also all the elements it should contain?
All which elements? Diagonal elements?
Yes, sir.
No, need not be. Transitive. Again, could you tell me, is this a transitive relation? Okay, let me just give you, you were convinced that 10 comma 10 was a transitive relations, right?
Yes, sir.
Then we were also telling that if these two conditions are not being fulfilled, we do not check for transitivity and we assume that it is a transitive relation. Now look at this, A comma B, okay? Do I
sir.
have B comma C in this relation?
No, sir.
I'm not going with the second. There is no and condition. So I will not be checking for its transitivity, and it is a transitive relation. So you see a single element can be a symmetric as well as transitive, but again, you have for symmetric, you will have to stick on to the definition again. But for transitive, you see that a relation, for it to be a transitive, you can have any number of elements, any elements, which can actually any single elements, but that is a transitive. For example, 10, 10. This is also transitive and this is also transitive, right?
Okay, sir.
But you see, this is symmetric, but this is not symmetric.
Yes, sir.
Right? Okay. So this is okay. If you can understand so much, that is
Yes, sir.
good
I
enough.
understood.
Yeah.
Thank you, sir.
All right. So now let's switch on to the. Yes, yes, please go ahead.
Sir, according to Google definition, I found that for symmetric, a relation should be all the elements containing A. So is it the case?
No, no, no. It should not. Not necessary.
So definition of Google
Definition
says,
says
also
if my B belongs to R, then B comma A should belongs to R. And your R is a subset of A cross A. That's all. Nothing else. This is only the definition. Okay.
okay, sir.
Okay. So should we go to the next one?
Yes, sir. In examination, we can have A cross B also. No?
You will not be given that kind of things. Okay.
Hello, sir.
Yeah.
For the worst.
Hello, sir.
Yes.
So can we discuss some qualifier question at the end of this session?
Sure, sure. We can do that.
Yeah.
Hello, am I audible, sir?
Yes, yes.
Actually, I have a general question regarding the qualifier exam. Can I ask it here?
Can we do it at the end?
Okay, sure. Thank you.
Yeah. Okay, so you see that we are fine with now type of relations, right? And I have just discussed 3 types with you. So that is something what I felt was important to discuss. So I discussed. If you want to learn more on that, you can actually see your first live session of this, where we have extensively discussed with number of examples, right? So that is learning part. But what we are doing right now is just from your examination point of view. Okay. Certainly it does not cover your 100% of the things, but of course it has got the highest weightage what we are teaching right now. Okay. So now you see this is another set of problems, as I was telling, comprehension type of questions, right? So you see that this is one type of questions what you can expect. Now you see you have been told that set A is something like this, right? Set B is this and set C is this. Then you have to find the cardinality of this. Okay. You see, it looks very complex, like these many operations we have to do. Then how do you approach these questions, right? So you see that in order to approach this question, what should be the thing is you have to first list the set A, B, C. Now this is given in set comprehension form. So you just write it in a builder form. So how do you get this? So could you list the set A?
3, 6, 9 up to 30.
All multiples of 3.
Up to 30.
Multiples of 9 and it goes up to 30. So we can just list them out. So 3,
6, 9, 12, 15, sir. Yeah, 18,
20,
21,
24, 27, and 30. Okay. What about B? It's multiples
of 4,
8,
12,
12, 16, 20,
16,
20,
24, 28.
28. Okay. So now we listed them.
Yes, sir.
What about C? Will continue.
6, 12,
6,
12, 18, 24, and 30. 30, sir. 30.
30.
Okay. So now you see that, of course, what we would have thought is, okay, this is multiples of 3, 4, and 6, and we might not list in the exam. Do not do that mistake. You might end up giving wrong answers. So it's always better to list these elements. Okay. So what we have done is we have listed all this A, B, C. Now you see this, what are the operations that we have to perform? It says B union C, A union C, and B union A. It's essentially this union this, this union this, and this union this, right? So we'll just list them out, right?
Yes.
So could you tell me what is A union B? And you see there is no intersection. It's all union, right? You do not land up getting intersection there, right? So now let's see, what do we get? What do we get A union B?
The 3,
3, 4,
3, 4,
6, 8, 9, 12.
3, 4,
6,
Sir, why are you not
8,
taking direct A
9,
minus B union C?
12, 15, 16.
16, 18, 20, 21, 24.
Sir, 15 is also there. 15 is missing.
Sir, 15.
15, sir.
Okay. You can see, somebody asked me, why are you not doing this? You can do that. Certainly you can do that. There's no harm. But I just want to go in a step-by-step manner so that others can also understand this.
Okay, thank you.
Sir, 12 after 15 is missing. Sir.
16.
16 is missing. Okay.
15
So
is
12,
also
15, 16.
15 and 16.
Okay. Rest all elements we have. Now, could we find out what is A minus
20?
20
Yes.
is also missing. Sir.
So 20 is
Just
also
write them
there.
in a better way. So 12, after 12, we
15.
have 15,
15, 16,
18,
18, 20, 21, 24,
27,
27, 28, 30.
30.
Sir, 24 नहीं आएगा.
24 is there.
It will come.
आएगा
It will.
सर आएगा.
दो बार नहीं
is there
आएगा.
inside it.
It will come
एक
once.
बार.
24 is
not
there,
come
it will
twice.
come.
Okay. So I think I have listed them all. So what is A minus A union B?
The element must be present
In A union B, but not in AI.
3, 9, 15, 21,
Elements
27.
must be in A, but not in A union B.
Yes.
9,
Okay.
15, 21, 27, 30.
No elements, sir.
Is there any elements?
No, sir.
No elements, sir. No
No
elements.
elements.
No elements.
Because see, what you are doing here is you are doing A union B, right? So you are adding all the elements of A, right? Certainly all elements of A is there, right?
A and
A
B.
minus A is 0. So it's a null
Yes.
set, right?
Oh,
Okay.
okay, sir.
We have, no, but we don't have to do that, right? A union B is here,
Actually, we need
but
to
we have to do C minus A
We
union
need
B.
to do this A minus B union C.
So we are actually doing this part, okay?
C.
C minus B union A, right? So A union B, whatever, it's both the same thing. So C minus A union B is what then? Could you tell me?
3, 4.
So I
6.
have
Sorry.
6, 12.
6, 12,
6.
18.
No,
18.
6 not 12 is there. 18 is also
6
there.
is there. So let's see which all things of these element is not there. Okay. So 6 is there in this. So I will not list them. So this is gone.
12 is also there.
There.
This is
18
all
is also
elements are
there.
there.
null set.
Again, this
Null
all are
set.
there.
Elements are there.
So I cannot have, again, this is a null set.
Sir,
right?
simply we can say that since 6, so 6 will have elements from 3 and 4 both. Because 6 means if we go by divisibility of 6,
Correct. That
then
is certainly
there
true.
will be no element because 6 is an even number and even like that, and also 3.
Certainly you can say that. So now again, yes. Now we can go with B union C. Okay. Now let's do what is B union C. So what is B union C then?
4, 6, 8.
4, 6, 8,
8,
12,
16, 18, 20, 24, 28,
28, 30.
28, 30. Okay, so now I have all these elements. Now what is that I have to do? A minus that, right? So A minus
B
B union C. So could you tell me what are these elements?
3, 9, 15,
3,
9,
9,
21,
15,
21,
27.
27, 30.
27. Okay, so now these are the elements that I'll have. So how many elements do I have? 1, 2, 3, 4, 5. So what is the cardinality of this? We can do that.
5.
Cardinality of this is 5, so we
5.
can just
5.
keep this aside. All right. So now we got this. Now what is left to us?
C.
That is A union
C.
C. A union C is what? So could you tell me A union C?
3,
3,
6,
6, 9, 12, 15,
18, 21,
18,
24,
3, 6, 9,
27,
12, 15,
3, 6, 9, 12,
15,
15,
16. 16 is
16?
no.
16 is not
16 is
there.
not here, sir.
Sorry.
21,
16 is not.
24,
27, 30.
all right. Now what we are going to do?
P
P minus
P minus A union C.
A union C. So what is this value?
8,
4, 8, 16,
4, 8, 16,
60, 20.
20,
20,
28.
28.
28 will also come. All right.
Cardinality is 10.
Yeah. So now what are they doing is taking union of all these. So union of this, and union of this. So certainly this is 0. So I mean null set. So we can just ignore that. So what is union of these two? So what do I get when I add these two?
10.
So I'll have 3,
3,
4,
4,
8,
8, 9,
9,
9,
15,
16,
16,
20,
20,
21,
21,
21.
27,
28.
28.
So how many elements do I have?
10.
10.
10. So what is the cardinality for
We are
that?
just adding both. So
Yeah. So you see there are other easier way for doing it. That is some logical things you can apply, as somebody was telling. Whatever is divisible by 6 is certainly divisible by 3 and 4.
we can use set diagram also, I guess.
But again, you cannot say that 3 and 4. You can use it in multiple ways. But this is something bit time consuming, but
Sir, it will get more confusing.
so whatever, yeah, that is also there, but it's okay if you can do it in this way. This is perfectly fine. Okay. And I don't think so this will take much time also. You can just practice, but do not take any error in listing these elements, right? So there is high likely chances that you might lose some elements while you're listing them, right? So you can just give a practice to these kind of questions. Okay.
Sir, what will be the means? How many number of elements will present in the set? Means
In exam?
Yeah, in exam means it will be 100 or 1000 like that.
No. Of course, will not give you that many.
Okay,
It
it
will
will
be
be
lesser
similar
than
to
30.
previous one.
Yeah, it
How
will be lesser
previous
than
one?
30.
Okay.
All right. So now this is just, I have taken a bigger example. I should have not been given that much, but it's okay. This is just for the practice purpose. This is how we'll approach this question. Okay. It will take time, but certainly you will get right here. All right. So this is one type of problems. And another type is this Venn diagram thing, right? So you would have seen it in your qualifier paper.
Yes, sir.
Which involved 3 Venn diagram.
Yes.
You can give practice to that questions, right? Or similar questions like that. All right. So what I'll do now is, that is something you can do. Okay. So I'm leaving that to you. So do that. Yes.
Can we ask questions at the end of session?
Sure.
So can you give us some practice question, because we have already practiced all of them.
All those things you have practiced?
Yes, sir.
Okay.
For
So
Venn diagram, can you give some practice?
Venn diagram questions.
Yes, sir.
Lots of questions.
okay, let me see what we can do for this. Of course, Venn diagram. See, in your exam, up to 3 Venn diagram, that's the highest we can give. So you can think of like 2 Venn diagram and 3 Venn diagram. But certainly you will get multiple questions online. You can just type that. You will get multiple questions. And those are like application based questions only involving Venn diagram, right? So you can just give a
Yes,
practice.
it was similar to how qualifier paper was there.
You
Last
can
3
just
questions.
give a practice to this. Even like if I have to practice, what I'll do is I'll just type Venn diagram problems, numerical problems. Just you'll get enough questions online. So just give a practice to some question, but it shouldn't be like you are giving much time to that itself. Just give it some, just practice some 4 or 5
That's why
questions.
I was asking with you, because it may go beyond our scope when we search on Google.
Okay, sir, you continue. Yeah, don't worry, it won't be very high things. Whatever they'll ask you is the highest what we have asked you. So don't worry about that. In your qualifier, what is the highest thing they can do is this maximum they can play around with a percentage, right? And it involves 3 Venn diagram. That's the highest they can go. And I think any Venn diagram type problems you can do if you can solve your, quiz questions. That certainly you can do. Okay, so don't worry about it. It's doable. Or if you have put it in the forum, we'll bring some questions, put it in the forum. We can do it, right? Others can also do it, isn't it? That we can do, right? Okay. So week 1, essentially, I think I have done. So what I told you was like, we have to focus on relations and then those comprehension type problems, which I discussed. And I'm assuming that you will do Venn diagram type problems. So I have already told you that what are the important questions. Okay, so you can just give a practice to it. Now coming to week 2.
सर हेलो
yes please.
क्रेडिट असाइनमेंट में वीक 1 का क्वेश्चन नंबर 3 वो समझ में नहीं आया था
we'll take it at the end. ठीक है,
Okay.
लास्ट में उस सब कर लेंगे. ठीक है. So now let's go with this particular things for week 2. So what is that essential thing that we have to remember is what are the equations of line, various forms, right? So now what we do with the, since this is more about this equations of line, so you know that what is the general form of equations of line?
Y equal to mx plus c.
That's
Y
the
equal
form.
to x plus c.
Ax
Ax plus b
or
y
ax
plus c
by
is equal
plus
to
c.
0.
By plus c is equal to
zero.
0.
Now yes, so how do you write in intercept form?
Y
y is equal to mx
X
plus
upon
c.
a plus y upon b is equals to 1.
x by a plus y by b.
From now
equal to
onwards, I will only do it because for other person they might get disturbed. Okay, so now what I'll do is I myself will write it everything. So you just have to recollect, okay, whether if I'm doing it right or wrong. Okay, so this will just, it will help you in that. So how do you write in intercept form? X by a plus y by b is equals to 1. So I'll mute all. Right, so this is one intercept form. So what I'll be doing is essentially I'll be doing graph as well so that you can understand this, right? So you know, so if this is the case, then this is the equation of this line. So maybe I can call this as 2. This is something 2 indicates my line. Okay, so just remember that. So what is this? This is a and this is b. So what do you mean this distance is a and this distance is b? Okay, so this is an intercept form. I hope this is okay. Then how do you get the other one? You will have, the next one is slope intercept form, right? So you will have slope intercept form. So how do you get this slope intercept form? So you have two forms here, right? So you can write this y intercept. When you are given y intercept, then how do you write? So you write like y is equals to mx plus c, and when you have just given x intercept, then how do you write? Y is equals to m times minus d. So here c is nothing but y intercept. So essentially, if I have to draw again the graph, you would see that the graph is something like this, and this is your c. Basically, this distance is c, and this is your, let's say 3.1. If this is 1 and this is 2. All right, and when you write this in x intercept form, so how does that graph look like? So it goes something like this. Let's say this is your d and this is your 3.2. All right, so this is how it looks like, okay, graphically when you do, right? So if I have to tell you, if I have just in a question, if I give you the slope for this line particular, that's 3.2, if I say, okay, your x intercept is 5 and let's say your slope is -2, what is the equation of line? So what do? You just have to substitute here, right? So what do you have to do? Y minus 2, the slope is given for me, and x will keep it as it is. And what is that I have given? X intercept, that is nothing but 5. So if I have to just rearrange it and then write it, so I get 2x plus 10. So this is the equation of line I get, right? So if this data are given, how do we get the equation of line? So essentially what are you doing here is you are finding the equations of a line when different conditions are given, right? So first condition was when both the intercepts were given, then this is what you get it in an intercept form. This is the equation of line. You can rearrange and get it in whatever form you want. Now, when slope intercept form, so what does it mean is one slope is given and one intercept is given, then how do you get the equation of line?
Y equals to mx plus c.
So you get it in a two ways. When y intercept is given, then you get it as y is equals to mx plus c. This is very popular among all of us, right? So this is something we get it in a y intercept form. And when x intercept is given, so this is what you get it. So when x intercept is given and a slope is given, this is how you get the equation of line. Okay. Then how else you can get the equation of line? So there is other way, right? So the other thing is called slope point form, right? Slope point form, what does it tells you? If a point is given to me and a slope is given, let's say a point 1, 2 is given to me and the slope of that particular line is given, then I can find the equation of line. So how is that? What is the formula for finding that? So the formula is y minus y naught, which is equals to m x minus x naught. So I will only tell, you don't tell it, okay, so that others can listen. Okay, you can just see that whether if I'm doing it right or wrong. Okay, so now this is what you get it in a slope intercept form. So what is this x naught and y naught? So x naught and y naught are nothing but this given point. So I'll repeat again. What are we doing here? We are just finding the equations of a line when some conditions are given, right? So when a point is given and a slope is given. So what is given here? A point is given. So what is my point? X naught, y naught. And what is my slope which is given to me, which is nothing but, let's say, m. So when these two are given, this is how I get the equation of line. So we'll do an example. So you see this, when 1 comma 2 is given and it is told that the slope for this line is 2. So then how do you get that equation of line? So you get it in this way. So how do you write? Y minus y naught. What is y naught here? 2. M, what is slope here? Let's say 2 is given to me, right? And x minus x naught. So what is x naught? This one. So this is nothing but this. Now what you have to do is you just have to rearrange and write. So this is going to be 2x. And when you take to the other side, this becomes 2. So y is equals to 2x plus 2. So how is that going to be? What is y-intercept? 2. So this is something going to be like this, right? So this is my third. Okay, so maybe I should say this is fourth, right? So this is the equation of line, right? When a slope and a point is given, right? So what
Excuse
did I
me,
do?
sir. Can you elaborate y minus 2 is equal to 2 times x minus 1? I don't get why it is plus 2.
Why is it plus 2?
Yeah, because if we expand 2x minus 2 and then there is a minus, then if we move it to the that side, then it will be only remaining 2 only, no?
No, 2x will remain.
Yeah, 2x it will be.
Okay,
That's
so
what
the
I am
slope was
asking.
given to you as this thing. So y minus 1 times 2 times x minus, oh, sorry, this is 2, right?
Sir, this is y naught.
Yes, yes.
So this is
Minus 2
2x,
plus
and
2
this,
cancel.
when it goes to the other side, I'm telling this will be, okay, 2x,
That's
2
what
times
I
2,
am
minus 2
saying.
plus
minus
2.
2 and plus 2, this will get 0.
Yes,
So y is
minus
equal
to
to
0. Y is equal to 2x.
y is
Yeah.
equals to 2x. Yeah, thanks. All right.
No problem.
So good that you are paying attention. All right. So you see that, see, so this is what you do, right? So now we got this slope point form as well. So I'll mute all again. Okay, so now we have another popular thing, 2-point forms, right? So when 2 points are given, nothing else is given, but just 2 point is given, how do you get the line, right? 2-point form. So essentially what we say is, this is 1 point. Let's say this is x0, x1, y1, and another point is given. Now we ask you to find the equation of line. So again, that is also doable. So what is the formula? So that formula is y minus y1 and y2 minus y1 divided by x2 minus x1 times x minus x1. Sorry, x2 minus, sorry, x minus x1. So
Sir,
this
it's
is what
y minus y1, y not also we can say.
You can say anything. You can write here as 2 also. But when you're writing 2, then you should make sure you're writing 2 here also.
Okay, sir. Okay, sir.
Okay. So let's go with your 2 only, right? Or this is changeable. You can write as 1, or if you're writing 1 here, then make sure you're writing 1 here as well. Okay. All right. So now how? So what is this essentially giving you? Y2 minus y1 upon x2 minus x1. This will give you slope.
Sir, m.
This is your slope. So which is nothing but your m, right? So when something is given to you directly, when let's say if this is given to you, this I'm telling it as an m. So essentially I'm telling you this is given, right? Where you can actually say 0 and 0 and it's done, right? So when 2 points are given, this is how 2-point form equations look like. So let's go with one example. So if I tell you 1 comma 1, and let me take it as 2 comma 2. It's very simple. So how do you do? First of all, y2 minus y1. First I will find out slope. So y2 is this. Let's consider this as x2 y2 and this as x1 y1. So what do you get from here? What is y2 minus y1? 2 minus 1. And here also you will have 2 minus 1, which is essentially 1 by 1, which is nothing but 1. So I got to know what is the slope for this. So what is 2 here? So this is 2 y minus 2, and I have simplified this thing already here, so which I got to be 1 into x minus, what is my x2? X2 is 2 again. So I can simply substitute this value. So now again y is equals to x. So when you simplify this, you get this. So now you see when 2 points were given, I was still able to get my equation of line. Okay, so these are some basic things, right? And this is how we get 2-point forms. 2 points will be given and you just have to find the equations of line. So this is all done. Okay. Now,
sir, conversion from one form to another,
that is very, very
important
simple.
or not?
That is certainly you can do, right? You don't really have to break your head.
Under
Now,
what conditions should we do it? Means, is there any relevant condition needed, or we can go with whatever we have been?
that is depends on you. See, what I'll do is mostly what we play around is y is equals to mx plus c and x upon a plus y upon b is equals to 1. With this, what I can do is I can get my x-intercept, and with this, see, generally what we do is we do a lot with this, right?
Yes.
So
But
whenever
which is the best equation to use, means, as a general case?
I mean, this is something you generally use. But see, if you want to plot an equation of a line, this is something you should go with, because from here
Yes.
you can get your x-intercepts and y-intercepts.
Y-intercepts.
But you see there, you might land up with something like complex values. So not complex, but a fraction values, but that is more tedious. So what you can do is you can play around here.
Okay, sir.
Right? Always visualize what happens is when a slope is given and intercept is given. Let's say a slope is 5 and intercept is 3. What do you do? Okay, so 3 is here. And if slope is 5, it will be more steeper. It will go like this. Done. I have got my equation of line. Right? Right? So this is like more advisable. Yeah. So, all right. So this is all what we did till now was equations of lines, right? Now, what all we can do with the lines?
Excuse me. The y-intercept and x-intercept are points where x and y are 0.
Right. So here, you see here y is 0. So that's why it's called as an x-intercept. And this x is 0 here. That is why this is y-intercept. Okay. Is it okay? Or you have any other fundamental question? Yeah.
Okay, sir.
Okay, no problem. Okay. So now let's go with the other things. Now we are done with one line. Now we can plot a line, or we can do what is like we can find the equation of a line in different conditions, right? These are all the possible things you can get, right? So with this, I can plot the line. Now what all things you have to do? See, now we'll play around with 2 lines. So when you have 2 lines, what all things you can have? You can have, let's say, a line 1 and a line 2, line 1 and line 2. Okay. So what you get is you can have this condition. Then what you can do, another thing is, how will this line look like in a space or in a single or in a two dimension? So how does this look like? Either they will be parallel or they might be collinear to each other. I mean to say the line 1 and line 2 are on itself, right? The other things what you can have is this line L1, right? This line L1 is intersecting with line L2. I can say this can also happen, right? What else we can have?
Yes, sir.
I can also have some other condition. Now, if they intersect, maybe they are intersecting perpendicularly, right? So L1 and L2, or they might intersect in itself, making an angle 0. So that is some condition discussed here, right? So this is what you can do, right? So what is the condition for 2 lines to be perpendicular to each other? What will happen with their slopes?
The slopes become equal.
The slopes
will be equal.
No. Slope will not be equal. I'm here. I'm coming this way.
Okay, then it will be minus 1.
Or let's start with this. Maybe we can start with this and then go. So if this makes an angle theta, acute angle, theta is lesser than 90 degree. Okay, then could you tell me what is tan theta?
M1 minus M2.
M1 minus M2
M1 minus M2 by 1 upon 1
plus M1
M2.
Okay. So now you know this. Okay. Yes. So now what is M1? M1 is slope of this line.
Yes.
And M2 is slope of this line. Okay. So now what am I doing? I'm finding this theta. So tan theta value I'm finding for this. Okay. So tan theta is nothing but it's basically okay. Let's not get into more trigonometry part. But for time being, there is something called tan theta, which is given like this: M1 minus M2 upon 1 divided by divided by 1 plus M2, right? So this is something we get. So now you see this. Now from here we'll come to this. Okay. So now what happens? What is tan 0? Can anybody tell me?
Tan 0 is 0.
Tan 0 is 0, right? So here a special case Now, or just look at this line. What is happening to this line when I bring it to this side? When I bring it to a single line, so what am I doing is I'm merging these two lines. What is happening?
Theta is
Theta
decreasing.
is becoming 0. So tan 0 is 0. So what is happening is this modulus m1 minus m2 divided by 1 plus m1 m2, sorry, m1 m2, this is equal to 0, because what I'm saying is they are merging in itself. So they are actually coming to this point, right? So they are something becoming
They are
M1,
equal to M2.
so this is becoming 0. So tan 0 is 0. So keep that in your mind. Now what I have to do, I just have to simplify this. I'll just take to the other side. This is gone. So what I'll be left with is m1 minus m2 is equals to 0,
M1 is equal to
or m1 is
M2.
equals to m2. So this is the condition for two lines to be parallel or collinear. So when two lines are parallel or collinear, what will happen? M1 will be equals to M2. Okay. So what do we mean by M1 equals to M2? That means the slope of one line and the slope of the other line will be same. Okay. Am I okay?
Yes, sir.
Yes, sir.
What is happening here is both the lines, their slope will be same. If their slope is same, then I can say they are either parallel or collinear. Okay. So this is all you have to know from this. Now come to this part. From here, we'll going jumping here. Now what is happening? Look at your tan theta value. It is becoming 90 degree. What is happening to your theta? Theta is becoming 90 degree. So special case, you can take it like this. So what is happening? What is tan 90?
Undefined.
Undefined, sir.
Or I can say it is 1 by sorry, 1
1
by 0.
by 0. Yes,
1 by 0, sir.
I can call this as 1 by 0. So this is something we'll get, right? So now I can simply modify, because this is theta, right? So now what I can do is I can bring this 1 by 0 m1 minus m2 upon 1 plus m1 m2. Now what I'll do, this is becoming undefined, and that is something we cannot deal with. So what we'll do, we'll just reciprocate these things. Okay. So when you do that reciprocal thing, so what will happen? 0 by 1. So this will also switch like that, m1 times m2 upon modulus of m1 m2. Can I do this? I can do this.
Yes, sir.
So 0 by 1 is nothing but what? 0.
Hmm.
And when this is 0 and anything, if I multiply with 0, that will become 0.
0.
Right. So what I'll be left with? m1 times m2 is equal plus 1 is equals to 0. So what I'll do is this 1 I'll send it to the other side. That turns out to be minus 1.
Minus 1.
Okay.
Yes, sir.
So now I got this also. So this is the condition for two lines to be what? Perpendicular. That means the slope of line 1 times the slope of line 2 is equal to minus 1. If this is happening, then I can say that these two lines are perpendicular to each other. Okay. Okay. Clear?
Yes, sir.
Yes, sir.
So now I'll take one questions. Y is equals to 2x plus 4 and y is equals to minus 2x plus 4. Are these two lines perpendicular to each other?
Yes, sir.
Check. What is my m1 from here? What is my m1 from here?
2.
What is my m2 from here?
Minus
Minus 2.
Okay. So 2
Sir,
times
it is
minus 2 is what? Minus 4.
Minus
Is this
4.
equal to minus 1?
No, sir.
Not equals
No,
to
sir,
minus
it's
1.
not.
So these two are not perpendicular. Okay, clear?
Okay.
Okay. So
Had
now,
it been minus 1 by 2, then it
now
will
tell
be
me.
perpendicular.
Now tell me.
Yes, sir, it's a perpendicular.
Yes, it is
line.
perpendicular. sir.
Now let's check this. So 2 into 1 is 1 by 2, which gives me what? This gets cancelled, so it will give me minus 1. So is minus 1. Now what I did was m1 times m2. Now this is my LHS. Now this is certainly equals to my RHS. What is my RHS? Minus 1. So LHS equals to RHS. Then I can say that these two lines are perpendicular to each other. Okay. So now you see that these kind of things. So what essentially you will get in the question is, okay, is these two lines parallel to each other? Is these two lines perpendicular to each other? So can you do that? You can do that. All you have to do is just check.
Excuse me, sir. There is also a case for theta greater than 90 degree.
Okay, so your formula changes there. Let's do not get into
Yeah,
that.
m1 plus m2 by 1 minus m1 into
That
m2.
changes, but do not go
minus
there.
tan theta.
Do not go there. Okay.
Okay, sir.
All right. So no doubt till here. We'll go to the next part. All right. So now
Yes,
what
sir.
we do is, now we have two lines and we have seen how do they intersect and all that, and this is all done. All right. So now let's see that what else we can do with these two lines. Now these two lines are given. So what else we can do? Now let's see this. These two lines are given, and then I'm telling, okay, find the distance between two lines. Let's say these two are parallel lines, L1 and L2, and I'm saying this is the distance between them. Okay. So now you have been asked to find out what is distance between these two lines, right? So you have the formula again for this. So maybe I can give the heading distance between two lines. Now you might ask, why are you doing only for parallel? Why are you not doing for any other particular lines? Why can't a line be, sorry, why can't you take perpendicular lines and tell what is the distance between these two lines? Could you actually think of anything like that?
So
Think of a
distance will vary.
perpendicular lines. Distance
Because
will vary at
perpendicular distance
every
is
place,
the
right?
minimum
Will
distance.
vary at
Yes,
every.
Right. So we
Every
can only
place.
talk about distance between two lines when they are parallel, right? Can I say that? Only when they are parallel, then itself
Yes,
I
sir.
can find out distance
Yes, sir.
between the two lines, right? So what is the formula then? So what is the distance formula? Modulus of ax1 plus by1 plus c upon root over of a square plus b square. Clear?
So it is a formula of point from a line.
Sir, C1
So,
minus C2.
sorry.
Sir, C1 minus C2
Sorry.
by root under
Thank
A
you. Thank you for
plus
correcting
B.
me. Yes. C1 minus C2 divided by root over of a square plus b square. Now this is the formula for finding this. Now, but what is this C1 and C2? You see this
Intercepts, sir.
intercepts. Now you see this. This is one line given to me, right? And let's say this is some equations like y is equals to mx plus c. Okay, let's say C1. So what is the other line that I can have here? Now this, I'm claiming that these two lines are perpendicular to each other. Oh, sorry, parallel to each other. Okay, and you have to find the distance. Now, when these two lines are parallel to each other, what is certainly happening? Slope are same. Can I say that? Two lines are parallel only if the slopes are
Yes,
same.
sir.
Yes, sir.
That means again here I'll have mx, but I can always vary my y-intercept, right? So
Intercept.
Yes, sir.
for this one it is C1.
Y-intercept.
For this one it is, let's say C2. Okay. So now, according to this condition, could you tell me what is my D?
What is the D?
What is my D?
Yeah, C1 minus C2 divided by square.
Wait, I'll mute all. Okay. So now you see this, when we write this AB, you must be wondering, okay, what is this A and B, right? What is this A and B? So this A and B are from the general formula. That is AX plus BY plus C1, AX plus BY plus C2. Now this is the two lines given you in the general form, and from general form we derived this formula, right? So what is A and B? Now from this, if I have to arrange this in a general form, how can I write this? I can write this as minus M X, right, plus Y minus C equals to 0. Can I do this?
Yes, sir.
Yes, sir.
Yes, sir. Okay. And what about this one?
Minus
Minus mx plus y
Plus y minus C2 equals to 0.
Now what I'll do is apply the same formula. So D is equals to C1 minus C2. So what is C1?
Sir, why that is minus C1?
I have taken everything on the left hand side. That's why.
Left hand side taken of the equal to.
You see, I have just
Okay, sir,
taken this
thank
on
you.
the left hand
Got
side.
it, got it, got it.
Okay. So what is your C1? In general form, here it was plus. Over here it's minus. So what is your C1? Minus C1 minus of minus C2. And this is in modulus, right? I'm clear? See, this formula has been derived from general form. And this C was nothing but it's a positive C. If you want to make this positive, what you will do is you'll just have negative of that, right? So this become minus C1 minus of minus C2, isn't it? Now, if I have to write this, in other words, what am I doing is I'm writing this, but see, I'm getting minus here, right? So if I have to come over this part, so what I'll do is I will write this in form of plus minus C1 and plus minus C2 equals to 0. Can I do this? Now
Sure.
these are
Yes,
in
sir.
this form, right? So what
Yeah,
I'm doing
yeah.
is I'm just simply substituting this here, and this I'm substituting it here, right, in the formula. Clear?
Sir, suppose we are having two lines, okay, and both equations are not same, but we know that both lines are parallel, so we can just means make them of the same coefficient a and b, and then we can calculate.
Yes, yes. But you'll have to make sure that they are parallel. Sometimes examiners might confuse you saying that they are not parallel lines and they are simply asking you to find out the distance between the two lines, and then you will land
And
up
so
nowhere.
then we can assume that both lines are parallel.
You can bring it in this way. Yes, when you find that this is happening, these two are being same, then yes, you can assume that.
And suppose
Which
if
is variable.
C1 and C2 are not given.
That is, then you can take as 0. If C1 and C2 is not given, let's say it is 0, could you tell me what is that line? Is that line collinear or parallel?
Collinear.
Collinear. Okay, so now let's come to this and quickly finish this off because we have
Sir?
our major last week for waiting for us. Yes.
Sir, I have one
But
doubt
basically,
here.
there is no collinear questions asked in the exam, right? That is like little out of subject, collinear.
It's in the subject, but we are not asking it much here, so we can just avoid that.
Sir,
Hmm.
sir, I have a doubt here.
Yes, yes,
So,
yes.
sir, like if the two equations are given and as well as those equations are parallel, so but that A and B of the second equation is like multiplied with two 2A and 2B. Do we need to downscale it like by
Yes, yes,
dividing
yes.
the whole equation?
Yes. Certainly, you will have to do that. You will have to bring it. You have to make sure the coefficient of x and y are same for both the equation, and then apply the formula.
Same
Okay?
thing I asked.
Yeah.
Actually.
Yeah. Okay. So okay, fine. So now here again, so what we did here was we brought it same things. Now you see the coefficient of x is same, minus m. Coefficient of y is same, which is nothing but 1. So we just wrote this formula in another nicer way, and we can say that from here what you can have is C2 minus C1. I'm just simplifying that, divided by 1 plus m square. Right? So this is something we got with the two lines. All right. Now what is distance between?
Sir, minus m and 1, where is 1 comes in
This is
denominator?
Here. Because what is your b in your formula? What is your b?
Acha, okay, sir. Okay. Coefficient of y.
Coefficient of y.
Got it. So
Yes,
now
sir.
this is this.
And sir, we can only take a distance between two parallel lines.
Only with the parallel lines you can find. Can you tell me what is a distance? What is a distance between two collinear lines, or what is the distance of a collinear line?
0, sir.
0, sir. Okay, so if you get some conditions like this, so essentially in that case, these both equations will be same, right?
Yes.
Yeah. So all right. So that is more than enough. Now let's do not get much here. Okay. So this is all okay. And the other thing that I have to tell you is like, what is the distance between? When a line and a point is given, right?
Yes,
so how do you get the distance? So now this is something x1, let's say x1, and this is, let's say, y1. Okay. And the equation for this line is, let's say, ax plus by plus c. Okay. Then how do you get this distance? This distance is nothing but the perpendicular distance. All right. So how do you get this? So the formula is a x1. Now you see this x1, okay, b y1 plus c upon root over of a square plus b square. You see this ABC, you know what it is, ABC, and you also have x1 and x2, and you can just substitute in this formula and get the value of your d, and this d is nothing but perpendicular distance of that point from this given line. Okay, so this is all you have to focus here in this week 3, but I want to give you a question. Any doubt here?
Yes, sir, I have a question.
Yes, please.
Sir, if we have two equation, 2x plus 4y plus 4 is equal to 0.
Sorry, tell me.
2x plus 4y plus 4 is equal to 0. And second equation is 4x plus 8y plus 6 is equal to 0. Sir, these two are parallel lines, right? Because their slopes are equal. Sir,
But then how do you use your formula, right? So you
yes,
bring
sir.
it in your same form. So just multiply this with 2. Okay.
So why we are multiplying?
Because you want to use your formula. That's all.
Make the
Sir,
coefficient equal.
Sir, sir, we have already.
Because your formula says in your formula
same
you
slope.
have C1
Just
minus
make
C2
your coefficient same.
I want to know why.
That's what I'm telling you. This is your formula for your distance of finding it between two parallel lines.
Yes.
What is your A and B? What is your A and B?
Okay, sir. No, I got it.
Right? Okay,
So
clear?
we have make it equal. Then we
Yes,
can
yes.
use A.
Yes.
Okay, sir.
Okay.
Hello, sir.
Yeah.
Sir, some question are equidistance. Sir, this is a confusing equidistance from the two lines.
Okay, so I think you're asking about your quiz problem, right?
Yes, sir.
You can just see what does it mean says a line was given. First of all, in that particular question, you have to find the line. After finding the line, there were 2 points given, and you have to check whether these 2 points are equidistant. That means the distance between, so you say you found the equation of line, let's say this was L1, and let's say this 1 point was given, let's say 2, 4, and another point was given, let's say 5, 6. Okay, this is the 2 points given to you. So what in that question essentially it was asked is the distance between this one, let's say D1, and this is D2. So D1 is equals to D2. This is what you have to check. Is D1 equals to D2? So what you could have done is individually you find the distance D1, individually you find distance D2, and then check if they are same. If it is same, then yes, the answer is true. Otherwise, it's false.
Yeah.
Okay, so now I have one question. Let's discuss this. Okay, so slope for this line is, let's say, -2. Okay, and this is, let's say, 1. This is also 1, and this is 1, and this is x. Could you tell me what is the value of x? So all of you just see, approach how to do this. I will not give you any time to solve, but those who want to solve it, do it. I will discuss directly the solution, and those who do not want to solve it, just think the approach for solving this. Okay, how do you solve this? Now the slope for this is -2, it says. Then what you should do, the first thing is, what you can do from here is you can find the equation of this line, considering this as 0, 0. Consider this as 0, 0. Okay, so if this is 0, 0, what is this point?
0, 3.
0, 3. Okay, what is this point?
0, no, not 0. 1,
1. So essentially what I should have done is I should have not even given you slope, and simply I should have asked you this question, right? So what, now you have 2 points, you can get the equation of line. Can you do that? Yes,
yes, sir.
You can get it in a 2-point form, right? Now what your life has become very easy. Now you have been given slope as well, so you don't really have to go with 2-point form. So I can get the equation of line AB. So what is the equation of line AB? I can take any of these points. So y minus 3, I'm taking this one, okay, this point. So y minus 3 minus 2 upon x minus 0. So let's not write that. So I can just simply write this as 2x. So y is equals to minus 2x plus 3. Yes?
Sir, y is 0. Okay, got it.
3 by 2. Answer is 3 by 2.
Sir, 0, 0 is given in the question, or did
we have to assume?
You have to choose any of these points to be your points. You will have to do some kind of construction. So that is something you will take. Okay, this is 0, 0.
In these type of, there was also a question of chessboard one. That also requires same type of logic.
So you will have to do some kind of thinking here. If these points are given, I want to bring them in a coordinate system. So how do I do?
So we can expect these type of questions.
You can certainly expect. So now you can assume that this is 0, 0. Now all I have to do is I have to find out x. So now you tell me, now here, what is your y value? Y value is
0, 1 plus.
So in this equation, can I substitute y equals to 0 and get this entire x? This will give me this entire x, right? It will not give me
0,
this x.
1 plus x will be the coordinate, I guess.
Minus 2x plus 3. So this will give me x equals to what?
3 by 2.
Yeah, 3 by 2. So x is equals to 3 by 2. So this is what I get. But this is entire x. Do not get confused with this. Do not write your answer 3 by 2 and then come up. Okay. Now I have to find out what is this x. So what I have to do,
3
I
by
just
2
have to
minus 1.
subtract this minus 1.
3 by 2
So
I
now
minus 1.
3 by 2 minus 1. So which gives you what? 3 by 2
Excuse
minus
me, sir. I
3 by 2,
want
which is
to
1 by 2.
understand how you use 0 for y.
Okay. What I was
Because at
telling
that
you
point
is
y is 0, na?
here. If this is my Cartesian plane, right? If this is my
Okay, then
x-axis,
x will vary. X will vary and y will remain same. So you just substituted the value of y is
Right.
equal to 0. Okay, got it.
So in your exam, do not substitute this value in term.
Okay, just to subtract that value means 1
Subtract
minus.
Can you, sir, please explain from y minus 3 equals to minus 2x from that?
from
Again,
here?
please.
From here?
Yeah. No. Just above.
This one.
Yep. From that to the bottom.
Okay, so you understood how we got this part?
Yep.
Okay. So to others, just to benefit others, I will explain it everything in details. Okay. So what is given to you was this 1, 1, 3 and x is given, and you have been asked to find out what is this value of x, or let me say what is the value of a, this a. All right. So this is something it has been asked. All right.
Yep.
So
okay,
this is a. Now what you have to do is you have to do some kind of assumption and construction. So what you can do is you can assume that this is my origin. Okay, so if it is 0, 0, certainly this point a is going to be 0, 3. Why? Because this 3 was given and this is lying here on the y-axis and this is your x-axis. Certainly you can do this drawing part, right? So now you got 0, 3. Clear?
Yep.
If this is 1 and this is 1, then what is this? 1, 1? This b, right? Clear? Now I can get these 2 points. Now if I have these 2 points, what should I do here? Now with these 2 points, I can get the equation of this line AB, but something is already given to me, that is slope is already given for me. So I will not get into 2-point form because that's a bit complex formula, right? Yep. So what I'll do is I'll just go with slope point form. So now a slope is given to me, right? So what do? And so is a slope, and whichever point you want, you can take. I see 0 here, so this is much easier to simplify. So I take this point. So slope -2 and point is 0, 3. So I'll just substitute that in the formula. So y minus 3, right, is equals to slope. What is the slope? 2 minus 2, x minus x naught. What is my x naught? X naught is 0. So let me not write that. So what I can do is I can simply write this as y is equals to -2x. So now what I'm doing is I'm just simplifying this and writing it a more nicer way, that is in the form of y is equals to something, right? So what I'll do is I'll just take this to the other side. So this becomes -2x and this goes to the other side. This becomes +3, right? So now this is what I obtained. All right. So now what we had to find out this part, right? Now what I'm seeing is at this point, this is becoming 0. And since I have to find out this one, why am I going with this is because see this equation, this line actually touches this, right? This is something going like this.
Okay. So
right,
yeah,
this line is something going like this. So I can certainly find what is this x value, complete x
okay.
value.
I was just confused about why you took 0, but now I understand that's because y becomes 0 at x. Okay, thank you.
All right. So now you see that when y becomes, at what value this is becoming 0. So at that is something you have to do simplification part. So when y becomes 0, for what value of x? So when you simplify this, you get that at x equals to 3 by 2, you notice that this is becoming 0. So that means this entire thing is 3 by 2, right?
Yes.
If this entire thing is 3 by 2, and if I chop off from here this 1, I will get this part, right? So what I'm doing is essentially I'm doing 3 by 2 minus 1. And when I simplify this, I get 1 by 2, which is nothing but half or 0.5. Okay, so your A is 0.5. So these are some kind of problems. You have enough problems to practice on this.
Sir, I didn't understand how we got 0 is equal to -2x plus 3.
Sorry?
How did we get 0 is equal to -2x plus 3?
Okay, this part?
Yeah, that part,
okay.
yes.
So this part is, see what is this? This is equation of which line? This line?
Yeah, yes, sir.
And
yes,
this,
sir.
You had been asked to find out A, and this is certainly lying over here itself, right? Now what is happening over here at this point? What is happening to your y value?
It's becoming 0.
So if I substitute 0, then I will get to know what is this my x value.
Yeah.
If I can get this value, then I just have to remove this one to get one A.
Yeah, yes, sir. Yes, sir.
Got it?
Yeah,
All right.
got it.
So
Hello,
this
sir.
yes.
Sir, in distance formula, root a square plus b square, I have to take this a plus b from equation 1 or equation 2.
So I was convinced that you understood that time and did not proceed there. All you have to do is when you get that form, right, you have to make that equation in the you have to bring it in the same form. So basically, where is that example? Okay, so I removed that. So somebody gave me an example: 2x plus 4y is equals to 5 equals to 0, and other thing was 4x plus
8y
8y plus, let's say, something 2 equals to 0. So if you want to use this formula, you'll have to make sure that these are same. The coefficient of, now this, you have to make sure this is in this form, right? Y is equals to bx plus c1 or c2, whatever, right?
Okay, it means a coefficient of x and y
Should be
has to be
same.
same.
So how do you make sure? Just multiply entire thing with 2.
Yes, sir.
Multiply over here too and also over here too. So it's
Yes, sir.
basically the same thing, right?
I got
All
it.
right. So let's go to the next week now. We have done enough
Hello,
with the
sir.
week 2. Yes.
सर if in the question अगर हमसे पूछा जाए कि point of intersection क्या है perpendicular line का, तो हमें सर कैसे ज्ञात करें?
Point of, sorry, what?
Point of intersection where two lines are interpolating each other.
Just equate them. See, what happens is, see what is happening, I'll tell you. You see, this is one equation of line y is equals to some mx plus c. Let me say this is y1 is equals to y equals to mx plus c. And I'm saying another equation of a line is, let's say this is y2 is equals to m2x plus c2. See, what happens is, at this point, what is happening to your y value? Your y1 is equals to y2. Is it happening? Tell me.
Yes. Sir,
Yes,
sir.
Right? It is happening
Yes,
or not?
sir.
At this point?
Yes, sir.
That is why you equate these two lines. You understood?
No, sir. How y1 is equal to y2?
It's because this is your
coordinates are same. Na?
This
Yes,
is your
yes, sir, yes,
first
sir.
equation. This is your second equation. And when they are intersecting, okay, let's say they are meeting somewhere. But what is happening to your y1 value?
Yes, sir. y1 is equal to y2.
This is an equation. It's not any point. So what is happening? Y1 is equals to y2. So essentially you do what? You equate these two lines. But why? Because that will be same here, right?
Yes,
so when
sir.
you equate, you are gone with your y values. Now you will be left with x. So when you simplify that, you will say that at this particular x value, they will be equal.
Yes, sir.
Right? Clear?
Yes, yes.
Okay. So let's go to the week 2 now. All right. See, we have to give more emphasis to all the weeks. So now let's just quickly go to this part. So in quadratic equation, see, in week 2, I think that is all you have to give focus to, nothing more. That is more than enough. Okay, but practice some of the questions and do not land up practicing more questions. Essentially, that will you really have to give more practice to your week 1 and 4. Okay, so plan your studies that way. So this is a bit blurry, I guess. So you see here, a question is given to you. So before going to this particular question, just let's recollect what we know first. So you know that, right? So what we have already studied, we know a quadratic equation. How do we write that quadratic equation? Ax square plus bx plus c. This is a general form of quadratic equation, right? Are we okay with
Yes,
this?
sir. Yes,
How
sir.
does this look like? How does this look like graphically? This C indicates what?
Parabola.
Let me say, I'm using this notation. F of x is equals to this thing.
Y
This is a
intercept is
parabola
C.
opening upward, downward. That I don't know. That is something happening there. So let's say this is happening something like this. Okay. When x is equals to 0, when x equals to 0, what do I get? This becomes C. That means this is C. Right?
Okay.
Right? So
Yes,
this
sir.
C tells me basically y intercepts, right? This C tells me what? Y intercepts. Now we are okay with this? Clear?
Yes, sir.
Yes, sir.
Okay. So now C tells me y intercept. Now what about the other things? Will this parabola be like this? Or this parabola could be like this as well? claiming this as C, right? Or this parabola could be like this as well, saying this as C, or this parabola could be like this as well, right? All these can happen, right?
Yes, sir.
Yes, sir.
Yes.
All these can happen. Like these are the
Yeah.
various possibilities that I can have.
Yeah.
Right. So now if this is the case, when will I understand whether this parabola opens upward, downward, or sidewise? Right? How do I understand this? Right? So that is something we will understand here, right? So I'll just quickly tell you how this all happens, right? So now you see this. This when A is positive, when this A leading coefficient is positive, what happens to your parabola? Open. So parabola opens upward. What happens to this when A is positive? Parabola opens upward. So opens upward means this mouth, it opens upward, or you can say this ending terms are on the same side, and that is on the positive y-axis side. Is it okay?
Yes,
Is
sir.
it okay? No confusion till now. Now let's go with negative A. When A is negative, then this goes downward. Parabola opens downward, right?
Yes,
So
sir.
now you got to know this as well. So when we say downwards, that means endings are on the same side, right? Endings are on the same side, and what is happening to your and on which direction? It is on the negative y side, right? So you see that when A is positive, this parabola opens upward on the positive y-axis, and when A is negative, this parabola opens downward in the negative y sides, right? Clear? And look at this. When we say this is my quadratic equations, I always have to make sure that A is not equals to 0. Why? Because when A becomes 0, what happens to this? It will become
won't be a
It become
quadratic.
equation of
Line,
line.
line
It
equation.
becomes a linear equation.
It becomes
A
a linear
linear
equation.
equation.
So for it to be a quadratic equation, I have to make sure that this is not equals to 0. Now we got to know something over here. So what all things we got to know? We got to know our y-intercepts. We also got to know the parabola opens upward or downward. And one more thing, which side it is going, that is something I don't know. So that is something you can determine by your vertex, right? You can determine by your vertex. Now vertex, how do you get? So vertex is, when we say vertex, we generally
Minus
use
B
coordinates,
divided
right?
Minus B
So minus
by
b
2A.
by 2a upon
Minus
f
b
of
by 2.
minus b by 2a. So this is your vertex form, right? This is something you write it in this way, right? So minus b by 2a tells you what? Tells you on which side this vertex is. Now, if you can identify this vertex side, then you can say if it is on the left side or right side, right? That is something you can say. So if I can find out this vertex, I can certainly say my parabola opens on the left-hand side or the right-hand side, right? And if it opens upward or downward, is certain that is something determined by what? The leading coefficient. And the sideways, or on which side, left-hand side or the right side, which side it is shifted, that is something determined by your vertex. Clear?
Sir,
Okay.
can you
Yes, sir.
explain it again?
Okay.
Yes, sir. It become confused.
Confusing? All right. So I'll just give you a summary here. So you
Sir?
see this example, I'll tell you. This is your intercept. This is your x-intercept. Sorry, not x-intercept, y-intercept. So now what I'm doing is I'm exploiting this f of x thing, right? What I'm saying, this c thing is nothing but my y-intercept. Whenever a quadratic equation is given, so maybe I can just write a quadratic equation. F of x is equals to, let's say, x square plus 4x plus 4. Okay, so this is one equation given to me. Now whenever I write this equation, the single constant term is my y-intercept. Keep this in your mind. So this is one point that you have to make a note of it, right? So this is first point that you have to keep it in your mind, that c is nothing but your y-intercept. It's not a x-intercept, right? Second point that you have to keep it in your mind is whether this parabola opens upward or downward. And how is that determined? It is determined by the leading coefficient. So is your a positive or negative? If a is positive, this parabola opens upward. And when we say upwards, what do we mean by upwards? That means when a is, just simply keep it in your mind, when a is positive, parabola opens upwards, that means it is on the y-axis side. And when a is negative, it opens downward towards the negative y-axis side. Okay, that is something you can keep it in your mind. Just with this A. So now what I did, I exploited this C and I exploited this A. Now I'm left with this B. What should I do? What will this B tells me? This tells me on which side it is there. It is on the left side or the right side, right? But just B does not tells me that. It is minus B by 2A tells me that whether it is going to be on the left hand side or the right hand side. That means the side thing of this parabola is determined by two coefficients, that is B and A. Clear?
Sir, from where vertex minus B upon 2A comes?
I'll come to this.
Okay.
Okay, so not this. Maybe I can give this heading, which side. You can choose, a better heading for this. So which side it opens, that is something determined by minus B by 2A. It is just determined by this. Now I'll take with this example and tell you quickly, and because we have a lot to do, now we are just left with half an hour to finish this thing. So now you
minus
see this.
B by 2 is x coordinate of the vertex.
So this tells you x coordinate of the vertex. So if that tells you, then you can certainly tell on which side it is, on the left hand side or the right hand side.
Left side.
You cannot say still. It depends on your B and A both. Right. So now let's understand with this. Okay. Now you see this f of x is x, this thing. So could you tell me what is your x-intercept? Sorry, y-intercept.
4.
Y-intercept is 4. So that is something we got it. This parabola opens upward or downward?
Upward.
Upward.
Upward. What is positive?
Upward, sir. Positive.
It opens upward.
Achieves
So on
minimum.
which side? Whether it is on the left hand side, the vertex is on the left hand side or the right hand side? What about minus B by 2?
Left hand side, sir.
Minus 4 by 2, which is nothing but minus 2. So that means, so now could you tell me this is happening somewhere at here, and this is my y-intercept. What is my y-intercept? 4.
4.
And this parabola opens upward, right? And this tells me that my vertex is somewhere over here. I need something more. What is that I need?
Y value.
You need to know what is the x-intercept value. Now I know this opens upward, right? But what is the x-intercepts now? That is something I'll have to know. So how do I get x-intercepts? Now I'm done with this part. And I'm certainly sure that this will open something like this, right? But at what accuracy, at what value on x it will happen that? So how will I get this? So for what value of f of x is nothing but, for what value of f of x, how do you get your x-intercept? X-intercept, you will get it by equating f of x equals to 0. Why do you equate x equals to 0?
Plus minus 2.
That is good that you have found out. How do you know that this will give me x-intercept? Because if this is, let's say, if this is my f of x, what is the f of x value over here? What is f of x value over here at this point?
Y equal to 0.
Y equals
What
to
is
0,
plus
sir.
2?
At this point, y equals to 0 and
No.
x
If
will
this
be
is your
varying.
f of x.
Plus 2.
No. Just tell me what is your f of x value here? F of x, not x. F of x.
So it will be 0.
F of x is 0 here.
2.
But I don't know what is that at what value of x, right?
2.
Consider this as f of x now. This is your f of x. At what value f of x is happening? At what value of f of x? What is the value of f of x at this point? It is going to be 0.
0.
0.
Okay. So could you tell me, are you confused?
Yes.
sir.
All right. Do not worry then. Do not be with me. I'll help you out here. Okay. So when I'm plotting a quadratic equation, I got to know what is my y-intercept. Okay. From my leading coefficient, I got to know whether this parabola opens upward or downward, right? And this tells me whether it is the vertex is on the left hand side or the right hand side of y-axis, right? So that is something I got to know. Now I am finding what is my x-intercept. So how do I get my x-intercept? How do you get usually x-intercept? When y is equals to mx plus c, what do you used to do? You used to make this 0. And then find the value, right? That is what we used to do, isn't it?
Yes.
That means for what particular value of x this becomes 0. This curve becomes 0. So that is something we have to find out, right? So that means
Minus 2.
essentially what I'm doing here is x square plus 4x plus 4 is equals to 0 for what value of x?
X equal
So
to
what?
minus 2.
There are two ways for
Minus
doing this.
2.
One is factorization. What
X
do you
plus
do?
2 का whole square.
One is factorization and another thing is using formula.
Discriminant.
So
What
minus
we
c
will do?
by
So what we will do here is we'll factorize this. So when you factorize this, how can you write this? 2x plus 2x plus 4 is equals to 0. So you can take out x minus x plus 2. Over here you can take out 2 common, right? And you will have x plus 2. So this is equals to 0. So what you will have is x plus 2 the whole square equals to 0. Right? Any doubt? At least here you should not have doubt. I understand you might miss your track in the graphing part, but here you are with me right now.
Yes, sir.
I'm just finding the root for this. When I'm finding the root, what do I mean? We are finding the x-intercepts. The roots are nothing but the x-intercepts. All clear now?
yes, sir.
Yes,
Yes,
sir. Roots are
So for
nothing but the
x-intercept,
x-intercepts.
we can use na minus c by a.
Yeah, we're going there. So now you have the formula. You have this minus b plus or minus root over of b square minus 4ac by 2a. So what is minus b? Sorry, what is b from here?
4.
So I'll write down here what is a is 1. What is
1,
b? b is
b
4.
4.
What is c?
C also
c is
4.
4. Okay, so what is my b? Minus, minus 4. Plus or minus, what is b square? This is 16. 4ac again 16 upon 2. So this will go to 0. Then I'm left with what? Minus 4 by 2, which is nothing but what? Minus 2. That means I got only one root, and that is nothing but at x equals to minus 2. This is the only x-intercept value. And from here also, when you simplify this, you get what? X equals to minus 2. So at x equals to minus 2, at only this value, this is...
Sir, we are having repeated root here. No?
Repeated root, yeah, but it is a single value. No?
Same.
Yeah,
It's the same value.
Repeated, seem repeated. But then as per the discriminant, if we calculate.
If you find out your d value, this is your, basically this itself is your discriminant, isn't it? Your discriminant will be what? 0. So you got 0.
0 means we will get unique value.
Same and repeated. Real.
So now let's come to this part. So now we saw that I just have only one x-intercept, and that is happening over here. And I'm very much convinced that this parabola opens upward, right? This parabola opens upward, something like this. Is it okay, all of you?
Yes, sir.
Okay, so now we can draw the graph of a quadratic equations. So how, again, we first have to find out what is our y-intercept. Then we have to find out whether the parabola opens upward or downward, whether the parabola is on the left hand side or the right hand side, something that is determined from here, right? What is the x-intercept value? That is something. So you got to know what is your x. How do you get x-intercept value? When you do this x-intercepting, you basically are finding the roots of that particular equation. Okay, and then you get the values. All right, till here, this is all okay. I think this is all we have to do. And you can use any of these methods. You can use factorization or formula for finding roots. So
Sir,
this
I
is
have a
all
doubt.
about. Tell me.
Sir, instead of doing it factorization, we can simply substitute that minus 2 in that f of x equation, and we can get that 0. Another point.
But how will you know that value?
Sir, by minus b by 2a, we can find minus 2. No, sir. So simply we can.
Over here, this was very clear. When the discriminant is 0, then certainly you can say minus b by 2a is one of your roots.
Okay.
Right. Over here, this is one case. But what you are telling is not applicable for all the cases.
Okay, sir. Okay.
Yeah. So, okay, fine. So now we understood this. Those who did not understood, don't worry. We'll do some more questions. You will understand it. Okay. Or you can watch these videos later on. So, all right. So what we did was we did all this graphing part. Okay. So now let's go again, come back to our very basic thing. What we are doing here is, we have been given a quadratic equations. Then what else we can have? You have, now you know that how to get the vertex, right? When an equation is given. Now, could you tell me what is the vertex of this equation?
-2.
The maximum
minus
point.
2 comma
-2.
Minus
comma
2.
0.
0.
Minus 2 comma 0.
2 comma 0.
This is the vertex. This is the
Zero.
vertex. Okay. Vertex is not just single x-intercept value, it's both x and y. Okay. When we say-
-2040.
Yeah. So now this is your vertex for this. Okay. Now this point is over here. All right. So now there is something called equations of a quadratic equation in a quadratic equations in a vertex form. So now you see this, any quadratic equation, let's say this is h comma k. If this is a vertex for this, and if I have to find out the equation of this quadratic equation, so how do you do this? Now you just write this in a vertex form. So how is that vertex form we get? So you get this, how do you write that? Y minus k is equals to a times x minus h, the whole square. Now this is the equation of a quadratic equation in a vertex form. Okay, so this is vertex form. So if I had to tell you, if your vertex is 2 comma 5, could you tell me what is your quadratic equation? And your a is,
Y
let's say,
minus
1.
5 is equal to.
So y minus 5 is equal to, what is your a? A is 1. X minus
2.
h. What is your h? 2. So now if you just rearrange and write, what do you get? Sorry, and this is whole square. So x minus 2 the whole square plus 5. So you can just simplify this and you will get some expression that will be your quadratic equation. Clear? Clear?
Yes, sir.
Sir, it is a
Okay.
general equation, sir. From
This is
vertex.
general equation. This is general equation. You can just memorize this, or you can put it in a formula.
Sir, if parabola is a downward, then his vertex is the maximum point, na?
We'll come to this maximum and minimum point. We'll do
Minimum
this more in week 4 when we are doing that. Okay, so now this is all clear. This is all okay with you?
Yes, sir.
Yes, sir. Yes, yes, yes.
Okay. I feel like some of you have lost track. There are some.
Yes, sir. Yes,
The
sir.
last one, this 4 comma k part.
Which one? Which one? Which
4
one?
comma k part. This one that you explained, the last part.
H comma
This
k.
one?
H comma k.
Yeah.
H comma k. This one.
Yeah.
Okay, this is a formula. You just by heart this formula. Okay, and this formula tells you equation of quadratic. A quadratic equation in vertex form. Quadratic equation.
How did you get a is equal to 1, sir?
I gave the value. Quadratic equation in vertex form. So that is something I told
A
you.
is what? Vertex?
A is the leading coefficient.
Okay, A is the leading coefficient here. And H is just the X value and K is just the Y value.
Now I have to ask you something. Okay. So just
sir, you have assumed A equals to 1.
A is
A
always
equals-
1.
No. I am telling you A is 1. I did not assume it. I told you, I was giving one example. When I told you if this is 2 comma 5 and A is 1, then what is the equation of a quadratic?
Okay.
Now I'll ask you in the other way around. Okay. Now if this is your equation, y is equals to, let's say, x minus 2 the whole square. What is the vertex for this equation?
0, 2.
0 comma or
Minus
2 comma 0 or 2 comma 0.
0. 2 comma 0, sir.
2 comma 0, sir.
Yes, x का value 2 आएगा तो 2 comma 0.
Right. Now let's compare with this. So what is happening to your k value? K is 0. A is 0. What is your A? Now compare this with this. What is your A? A is 1.
1.
Okay. And what is your H?
Plus 2.
Okay. So now could you tell me, now you know that H and K represents your what? Vertex?
Yes, sir.
Could you tell me what is the vertex for this? What is the vertex for this? 2 comma
0.
So you see, you did not had to find out any of these things, but you got it directly, right? Okay. Now this is simple. Now if I have to tell you another equation, if I have given you another equation, let's say this is x plus 5 plus 2. Now tell me what is the vertex for this equation. What generally you would have done if this formula was not known to you is you would have expanded this, you would have done the graph for this. If not graph, you would have actually founded its vertex, and then you would have given the answer, right? But you don't really have to do that, all that expansion part. All you can do is just compare with that part, compare with this, right? Could you tell me what is, and let me say this is
minus 5
minus 5 minus 2 comma 5.
Just a minute, just a minute. This is
Y minus 2 equal to x plus 5 ka whole square.
Okay, just a minute. Could you tell me what is k?
K is equal to minus 2.
No, k is 2. No, sorry. What is sorry. What is your what is your k? K is 2.
2. 2 yeah, minus 2, sir.
Minus 2, sir.
Why minus?
Minus 2.
No, not minus 2. Why? Just compare this with this.
Sorry, 2. Yes, sir. Only 2.
What you will do is you will bring this to the other side, and then you will have what? Minus 2 x plus 5 the whole square.
Formula is already minus included.
X plus 5 the whole square. So what are you doing now? What is your k?
Minus of minus 2. Y minus
Why minus of minus 2? Directly this is k. Only 2. Why do you want to take minus of? You don't have to. You see here, this is your general form, and you are writing.
Yes, understood, sir.
Understood, right? So k is 2. Now what is your a?
Minus 2.
Minus 2.
Minus 2.
And what is your h?
Minus 5.
5.
Minus 5. Do not tell 5 because we will catch you in your example. Okay. So now tell me what is your vertex?
Minus 5 comma
minus 5 2.
5 comma 2.
Minus 5 comma
2.
2.
So you see,
And it is facing
all you have to
downward.
do is you just rearrange this and get the answer. Otherwise, how you would have done is, you would have first expanded this, then you know how to get that vertex minus b by 2a, comma f of minus b by 2a. This would have been much more lengthier time, and you would have landed up getting the answer, but you would have taken much time. But you can certainly do this. So memorize this. This is important. Okay, memorize this. All right. So now let's go to the next part, the question which I showed you that time. So graphing part, who did not get it, don't worry, just see that video again. I think you should learn that, because as you come ahead with the maths course, graphing will always kill you if you're not knowing the things. So please learn that. Okay. Graphing is really important. Okay, now come to this part. What will be your approach for solving this question? So a question is given to you, a runner targets. So there are so many things. Now, if you read this question, we might lose the track, and you see, first, what does it tell us? A runner targets to dissipates 480 kilocalories. Now, this itself will confuse most of us. Okay,
this is f of x final value. This is f of x.
E is f of x. E is f of x. So what is E? E is basically, now this see, whenever you go to your examination and when the question is asked, first look at the equation. What is this equation? A quadratic equation. That's it. You got all you should recollect. What you have to do is, okay, I have to find out roots. Then what all I can think of? I can think of vertex. I can think of y-intercept and all that, blah, 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 right? So that is all. Now you see here, what is it says is a runner targets to dissipate 480 kilocalories of energy per day by running, and he stops running as soon as he achieves its target. Okay, let E be the energy left to dissipate in kilocalories after running x kilometer. What is it? Kilometer. Okay, defined as something like this. So what does this E indicates? E indicates he is losing that much energy. Okay, when x is some value, when x is, let's say, 100, when x is 5, the energy will be somewhat higher value. When x is, let's say, some 60, when x is somewhat, let's say, 8, then what will happen? He will lose all his
zero.
Yeah, he'll lose all his energy, right? So now what is happening? So he's basically running, and this equation tells you that he's losing his energy as per this equation. Okay, now what you have to find out, he practices on a track of a perimeter. Now let's say on a track of a perimeter 250 kilometers. How many rounds does he have? Does he runs per day if he achieves his target? Okay, So there are so many things. Those who know also this quadratic equation will lose your track here. I mean, the questions are like that. The question is like that. So what is happening is, first of all, there is a running track. Now pay attention to me. I'm just telling you how to solve these kind of questions. You can practice this question afterwards. Now this is a running track, which is what is its perimeter? 250 meters. Okay. This equation is given to me, and equation tells what? E is equals to minus 7.5 x square minus 64. Okay, so what is happening here is some kilocalories of energy per day. He basically a runner, he stops running as soon as he achieves the target. Okay, so now what is happening? When will he stop? Can someone tell me?
When x is equal to 0.
When E is equals to 0, when his energy becomes 0, he will stop running. So when will that become 0?
When x is equal to 8.
When E is equals to 0, for what value? Square minus 64. So what will happen? I'll just simplify this. So x square minus 64, or this implies what? X square is equals to 64, or x is nothing but plus or minus 8. But you see, what is this x? What is this x tells you?
Kilometers.
Kilometers, that many kilometers he runs. But kilometer cannot be negative, right? It's some positive quantity, right? So x will be positive, so this will be 8. So for 8 when x is equals to 8, he loses his energy, right? So 8 is what? 8 is what? Kilometer. That means when he runs how many meters? 8 kilometers, he loses his what? Energy. That means if he runs 8,000 meters, he loses his energy. Right. That is what it says. If he runs this many meters, that is 800 meters, he completely exhausts. He loses all his energy. Right. Now he is running on this track, and what, as for the amount of energy he is given, he can run how many? He can run 800. How like to what distance he can run? He can run up to a maximum distance of 800 meters, right? Now if he can run
8,000 meters.
Sorry, 8,000 meters. Now if that is the case, then if this is your track, which is of 250 meters, then how many times will he complete this track?
32.
8,000 by 250
divided by 250 equals to 32.
So this is equals to how much? Okay. So those, I don't know if you got this. Did you understood this? So there is another way of telling it.
Yes, sir.
If you still did not get it, just take it in another way. Runner will stop when his whole energy get dissipated. This means energy left to dissipate is 0. So that is something, this will happen, right? When E becomes 0, which implies this has to be equals to 0. So which implies x plus or minus 8. Now that this indicates what? X denotes the kilometer runs by the runner. So it will always be positive, right? So that is something we got it. So this is 8 kilometers. So we have to convert this into meters. So 8,000 meters. Just convert into this and then simplify to get your answer. Okay. I hope this is okay.
Yeah.
Okay.
Yes.
This is okay.
Yes, sir.
Yes, sir. Clear,
So
sir.
now in
These
quadratic,
kinds of questions are expected in exam.
very much, very much.
Okay.
You can practice this
Something
question.
they have given kilocalories, we no need to care about that, right?
That is something that is simply given. This data is redundant. Okay.
It's just for confusion.
No, it's not for confusion. We have to give some values, right? Like this is, we have to tell, no, like how much energy he has. It's not a confusion. Okay, this was something else. All right, so we got to know how to solve this question. So now in week 4, you are expected to solve an SSE problem. Okay, and that is something there in your mock, which was given earlier. Okay, that is something you have to pay attention to. So do pay attention for that particular question. Solve somewhat questions like that. Okay.
Sir, hello, sir.
Yeah.
Sir, after this session, you will provide slides.
Slides of what?
Sir, this session slides.
This session slides, I have written it in very rough way.
Okay,
These
sir.
contents, since this is very rough way, it's not good to
You can take from YouTube.
You can take from the YouTube. Yeah, that is something you can.
Okay, thank you.
Take these questions, but do practice these questions. These are important. Okay. Now you see, now we are going to deal with some important thing, that is your week 4. Now we have entered week 4. This is like very important week because you would have seen that maximum weightage is coming from here, right? You can expect some 40 marks questions, 40%, 35 to 40%, right? So even if you attend this week and you are thorough with this week, you can answer questions, right? So the question is given to you here. I'm not going with the normal way, like, you know, what is addition, subtraction, and multiplication and division of a polynomial. That is something I expect that you should be knowing, right? And can I assume that you know the graphing of polynomial?
Yes, sir.
I can assume that you
No,
know how to
no.
draw the graph.
Could you please
No, sir.
revise that once because it's
Yes.
important.
So there are,
No, sir.
but there are a lot of you who can actually, whom I can expect that who can do the graphing. So we can skip the graphing, and or we can not skip it. Let's do something, and you know, like as we are doing the problems, I'll tell you how to do the graphing part. Okay. So a question is given to you here. So we are in week 4 now. Okay. Now we are in week 4, and week 4, I'm not telling you what is addition, subtraction, multiplication, division. This is something very, very small things that we shouldn't be discussing, and that is not really important from your examination point of view as well. That is something you will know just like that. So that's what I'm assuming. What is very important is your graphing, and that is something we'll do here, and we'll spend some time. Okay. So now
Take,
a question.
take one example, sir. Graphing.
I'll do that. I'll take 2 examples. Okay, because I have 2 questions, so I can just tell you with this. So now you see this. There's a question asked. Levi wrote 15 assignments. How many? 15. His scores in each assignment, which is represented as Rn. Okay, so Rn indicates his score. Okay, and that score is something governed like this. Okay, whatever score, I don't know what is his maximum score for this particular, for those particular assignments. We are not sure of that. That is not at all important. What is important is this equation represents his scores in the assignments, and this n represents the number of assignments, that is 1, 2, 3, 4, 5, 6. So this indicates that when n is 15, so on 15th assignment, what is his score? When n is 14, on 14th, what is his score? These kind of things it is represented. Now see here, it is been told he should score 40 or above. What is it says? 40. So even if he scores 40, he passes the assignments. So 40 plus, okay, if he scores, he passes the assignments. In total, how many assignments did Levi pass? Okay, so even if he scores 40, he passes the exams. So could someone tell me the answer by now, if you know the graphing of polynomials, or like however you can do?
$11.
11.
Yeah, yes, 11.
Okay, let's see that if it is right. Okay, so we can see that. So what we have to do is, now you see there is a big polynomial here. What is its degree? 2, 3, 4, 5, 6 degree polynomial. Okay.
6 degree.
So what I'll tell you is,
for 15 he doesn't.
Okay, so now let's understand how to solve this. Now R of n is given. R of n is nothing but n square upon some 1000, n minus 3, n minus 7, n minus 13, n minus 15 plus 40. Now what does it tell you? If he scores 40 and above, he passes that. Let's say if this graph was something like this, okay, if some graph is something like this, and these are the n values, could you tell me which is that region? Let me say this is region 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Could you tell me which are those regions where he passes the exams?
Above the. So what is that baseline? It is 40 or less
this
than
is
40?
R of n minus 40.
Oh, I don't know.
Above the x-axis.
Above the x-axis.
Above the x-axis.
58.
So 258. 258. So these are the regions where I can say that he has passed the exams. If this represents R of n minus 40. Right?
Yes, above the baseline, sir.
No, this is not the baseline. This graph I have told, like roughly this graph is something like this. Then I can say that this is where he's passing this exam, because this is where he's getting 40 plus, right? Now you see, if this R of n is 40, then this becomes 0. That means it will be here. When it is 41, must be here. When it is 42, must be here, somewhere like this, right? I hope that is okay.
Yes.
So what was important here to understand, that how do I get the graph now? Isn't it? That's the problem, isn't it? Now I can happily tell, okay, these are the regions where I can say he's getting 40 plus. But how do you get that graph? That is something comes with the graphing knowledge.
Sir, answer is 3 or 4.
What?
The answer for this
Answer
question
we
is
did not
3 or
arrive.
4.
I don't know the answer. We'll
I
solve
guess
this.
answer is
Somebody
4.
told answer as 11. You are telling answer as 4. So let's make a note of it. Okay. So now what we are telling is, for these kind of question, how do you approach? So what I'll do is, I will say R of n minus 40, and I will bring this into a nice equation that is of this form, that is n square minus 1000, n minus 3, n minus 7, n minus 13, and n minus 15. So I don't know how.
Basically this 40 that is like a constant term that we are taking as a baseline.
No,
Or
that is nothing.
no, but actually the confusion is that he has scored 40 and the constant part is also 40.
I'll tell you. So
Yes, sir.
what is happening is, what happens when your n is 3?
So the whole equation becomes 0. R of n minus 40 is equal to 0.
Tell me, what happens when n is 3? This becomes 0.
40 is just telling that the x is that y equals
Sir,
to 40.
it becomes 0.
It becomes 0. So entire equation becomes 0. So when this entire equation becomes 0, so what you can simply still write this as, when you take this to the other side. 40. So at what value it is becoming 40? Could you tell me?
When n is equals to 3.
When x is in what?
3, 7, 13, and 15.
Or you can say R of n is equals to 40 for what value of x?
3, 7, 13, 15.
Yes.
Okay, so not x, but n here.
Yeah.
So 3, 7, 13, 14. So you're telling 4 as the answer, right? So that's how you were telling.
What about n square then?
I'm sorry. Yeah.
The entire equation will become 0 at these points, because n square is multiplied by
0. But you see in the
even if
question,
one term becomes 0, then entire equation.
I'll tell you. Let me go there. But we were convinced that time, right? When this was these regions, when it was there, then it was becoming. He passes those assignments.
Yes, sir.
4.
So you see, enough with the thinking part. Now let's go with the graphings and understand this. How is this happening? Okay. So what are we doing over here is, why are we taking this 40 to the other side? It's just to tell you that if this region is greater than something, now you tell me you tell me if this is positive, if this value is positive, then positive plus 40 will always be positive.
Yes, sir.
Right? Positive plus positive, it will always be positive. I mean, positive plus 40 will always make it 40 plus. Right? So what I can do is I can graph this polynomial and make sure in which all region it is greater than 40. Right? And I can figure out those regions or those value of n are the number of assignments where he passes the things, right? So how do we do the graphing part now? So now you see this, whenever you do the graphing part, you first find what is the degree of this polynomial. What is the degree of this polynomial? So step number 1, what is the degree of this polynomial?
1, 2, 3,
6.
6, sir.
Is it odd, even?
Or even.
Even degree. Okay, what about your step 2? What is the leading coefficient?
Same side.
Leading coefficient term. What is the leading coefficient term?
Positive n square by 1000. Positive, sir.
Positive, and what is it? Like, is it 1, 2, 3? It's going to be 1 basically, right? You multiply with whatever these values.
Yeah,
Your
because here we can't say n is a variable.
So n is the variable. Your step 2, what does it say is, what about the degree of not the degree? So maybe I can say that first step is you have to find the degree of R of n minus 40. What is it?
So 6 and it is even.
Okay. Leading coefficient. Nature of leading coefficient.
Positive, sir.
positive.
Leading coefficient is positive. Okay. Then what do I have? What do I have to find out next? Step 3. I think this is okay. What are the x-intercepts?
3, 7, 15.
3, 7, 13, and 15.
7, 13.
0. How can you forget 0?
Oh, yes.
0, 3, 7, 13. This is not very important, so we can
So
just
0 doesn't belong to set of n, right?
That's okay, but we are doing the graphing part. That is something we'll omit when we are doing the
Okay,
graphing.
so we have to take care.
So now we have to understand this part. Now this is okay. Now we got to know these two informations. Now recall what happens when what happens to your degree
both
when it
the
is
ends open on the same side, sir.
when it is an even degree polynomial and coefficient is positive. Even degree and the coefficient is positive. It is going to be something parabola opening on the same side, and if this is positive, then it will be on the positive y-axis side. Okay. And when it is
Sir, can you repeat once more time from this graphing parabola?
Fine. So what I'm trying to say is, whenever there is degree, whenever there is an even degree, the parabola will be on the same side. Whenever there is an even degree, the parabola is on the same side. Let's say if it is an even degree, let's say if it is 100, okay, so it will be on the same side. It's going to be either this side or this side. The endings will be on the same side. But when it is an odd degree, now before going there, could you tell me what is the graph of x square? Something like this?
Yes,
sir. Yes, sir.
Minus x square is something going to be downwards opening parabola.
Yes.
Right. What is the graph for x to the power of 4? See, this is your x square. Okay. This is your
That
x
is
to the
more
power of
flattered.
More flattened towards.
Maybe I can say this is your x square. This is your x to the power of 4.
Yes.
And when I say x to the power of 100, how will the graph look like? Something more steeper and
more steeper towards the roots.
But you see, what essential is the endings are on the same side. It's not crossing, right? The endings are on the same side. That is what I'm saying. But look at x cube. What is the graph for x cube? Like this. What happens to your endings? You're on the opposite side. Clear?
Yes, sir.
When it is an odd degree, the endings are on the opposite side. When it is an even degree, the endings are on the same side. Okay. Now look at this. You understood that part? Okay, all clear?
Yes, sir.
Having known that, what about this leading coefficient terms? When the leading coefficient is positive, now let me take one example, ax square, or let's not go with ax square, or simply we can just x square plus, okay, let's take x square.
Excuse me, sir.
Or 2x square. Yes.
Yeah, actually, sir, I am having my mid-semester test of my mainstream course.
You can watch
that
this
is live
video
test. So, is this session is recorded on YouTube or?
Yes. It is
Yeah,
there
thank
in
you, sir.
Yeah. All right. So this is 2x square. So what happens here? 2x square means what? How will the graph look like? Something like this, right? And why it is on this side? Why the endings are on the positive side? Because the leading coefficient is positive. Now look at this part, 2x square minus 2x square. What happens to your graph? It goes something like this. Look at your ending side. Which side it is?
Negative side.
Negative side. Okay. Now comes to x cube. Let's understand this. X cube. Simply, let's say 2x cube. How will the graph look like? Something like this.
Crosses the x-axis.
But you see the crossing thing? It's happening like this. But the moment I give it minus 2x cube, how does it happen? Something like this.
Yes, sir.
The other way around. So just keep it in your mind, these two graphs. Okay. Okay. So now we understood when the leading coefficient, there is something we are understanding. When the degree is even, the parabola opens on the same side. Am I clear?
Yes.
But the leading coefficient tells you whether it will be above y-axis, above x-axis or below x-axis. That is something we know that, right? All clear?
Yes, sir.
Yes, sir.
Okay. As if now this is okay. Now, if we understood so much, that's well and good. Now understand from this. If this is your polynomial, we got to know what is the degree. 4. And is it even?
Yes, sir.
Yes, sir. Yes. And leading coefficient is positive. Certainly, what is happening then? Something is going to be like this. Endings are on the same side and it is opening positive direction, positive y-axis side, right?
Yes,
Something
sir.
like this. I'm not sure what is happening inside, right? So that is something we'll have to figure out, right? How do we do this? So now this is your n and this is your f of n, right? So let's say this f of n. So now what could you tell me what all the roots you can get from here? Now these things will tell you the roots of this polynomial. So at n equals to 0, this entire thing becomes 0. So can I say, let's say this is your 0, this is your 3, this has 7, this has 13, let's say this is 15. Okay, so at all, for what all values it is becoming 0? When x is 0, you see your curve is at,
Yes, sir.
when 15 it is 0, right? Now we'll have to figure out what is happening to this. What is the degree for this polynomial? At 3, what is happening? It's 1.
Yes,
It's
sir.
a linear.
So it's a linear, means it has to cross in a linear fashion. So how will it cross here? It'll just cross in a linear fashion. Had it been cube, it would have been gone like this. Had it been quadratic, you would have bounced it back.
It's a straight line.
So this is just a straight line. So what happens? It goes like this, crosses like this. Look at over here. Had it been square over here, it would have bounced back like this.
Excuse me, sir.
But at n square, it would be bounce back, right?
Yes, sir. At n square, it will be bounce back.
At n, okay, so we'll go there. Okay, thanks for pointing that. So now this is very much sure that it was going like this. The curve was going to be like this. At n square, what is happening? It is bouncing back as you are telling. So it will bounce back like this.
Then a straight line.
Over here, what will happen? It will cross in a linear fashion. So it will bend. It will go cross in a linear fashion like this. Over here again, it is 1. So it will go like this.
Again, cross.
Over here, it is 1. So it will cross like this. Over here again, it is linear. So it will go like this. So now this is the graph of your f. So this is your graph of your r of n minus 40. Clear? So now let's understand more with this.
Can you just elaborate?
So now,
bounce back.
This bounce back.
How n to n squared you can bounce back?
Don't worry about this. I'll make sure in this today's session you will understand this. Don't worry.
Thank you.
So now first let's complete this part. Now what is happening is we drew the graph for this. Okay. Now all we have to do is, now if this is Rn minus 40. So this curve represents Rn minus 40. This is at this place it is 40. Can I say at this place it is 40? Can I say that?
Yes, sir.
Yes, sir.
Yes, sir.
Over
Yes, sir.
here it is
The
lesser
baseline
than
is 40.
40. Over here it is lesser than 40. Over here it is lesser than 40.
Yes, sir.
The entire
Yes,
value.
sir.
Yes,
It is only these regions where it is becoming what? Positive. This region,
than
this
40.
region. Right. So now what? What
Sir,
does
on
our
the
function
x-axis
tell?
it will be 40, sir. Marks.
Yeah, on x-axis it is going to be 40. But above x-axis it is more than 40. So what you have to find out? You have to find out all that value of n where it is more than 40. Right? Right. 40 and above. And you see your x belongs to what? It starts from 1. So we will start from here. This is somewhere 1. I will not be counting this part. This is not counted. Basically, this part of the graph we will not count. But the graphing for this is essentially this. But now we are counting what? The number of assignments where he scores more than 40. Okay. That is what we are doing, right? So now if that is something known to us, now at 1, certainly the value is more, right? It is greater than 40. Can I say that?
Yes, yes, sir.
Yes, sir.
Yes, sir.
So now I am just listing the number of assignment where he scores more than 40. Okay. So x, for which all values he scores more than 40. So at 1, he scores more than 40. What happens at 2?
2 is more than 40.
More than 40.
2 is more than 40.
3
Is
is
3 in my
40.
list? 3 is in my list.
Yes,
Just
sir.
because he scores 40, then he passes, right? Can I
He
take
exactly scored 40 at 3.
he exactly scores 40 at 3. Can I take 4?
No.
5?
No, sir.
6?
No, sir.
Can I take 7?
Yes,
Yes.
Yes, sir.
I can take 7. Can I take any other values? Can I take 8?
Yes, sir.
Yes.
Yes, that goes in my list. What about 9? Yes,
Yes,
again,
sir.
that goes in my list. 10?
Yes.
Yes, again 10 goes in my list.
11
11?
also.
11, 12.
Again
12.
11, 12, 13.
13.
Can I take 14?
No.
No.
No,
No,
no.
not take 14.
No.
15?
Sir,
Only
15,
15 we
16.
can.
Can I
50
take
only.
16?
No.
No.
sir.
No, no. Why?
16.
Why can't I take 16?
Not my list.
Because he is only having only 15 assignments.
He just have to do 15 assignments.
Oh, yeah.
That's all. Okay. So that's why we cannot take more than that. All right. So how many values do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. So somebody told 11 in the very beginning. Who was that?
Sir, me, Himanshu Dikshit.
Oh, congratulations. Good.
Failure
Good,
makes the
Himanshu.
man perfect, sir.
Yeah.
Good. But don't worry, all of you will pass. Don't worry, this time all of you will become VP.
I have a doubt.
So now essentially what we have to understand from this is first thing that you have to understand was shifting this to the other side and making an understanding that if he scores more than this, then certainly he is passing the assignments. Having known that, the second part we have to know is how to do the graph for this polynomial, right? That is something we have to know. Now, once we can do the graph for this polynomial, then I can extract all the possible data which was asked in the questions. Can I do this?
Yes, sir.
Okay. So now, there are two components in this, three components.
Sir, I have a question.
I'll take up that question. Let me finish these three components. First
Okay,
component was shifting this to the other side, this 40 to the other side, by understanding that, yeah, if he scores 40 and above, then he will pass the assignments. Second component was, I have to draw the graph. Third component is choosing the right number of assignments, right? So there were three components for doing this, right? Having known this, there are some other variations in this question that I can do. Sometimes here, what it is this nice factors is given to you. Sometimes the factors will not be given. Then what do? You factorize it at that point of time. Okay. I hope I'm clear on this.
Yes,
Sometimes the factors won't be given to you, but when you want to do the graphing part, you need factors. If you don't have factors, you cannot do the graphing. Understand this?
Yes.
You will always have to factorize this. Let's say if this equation was not given like this, if it was given n square by 1000, okay, and it was given as something, let's say 2, maybe I can say it as x square plus 4x plus 4, or let's say this is 4x cube x square x. How will you would have done this? In that case,
So taken out 4 common.
Okay, so maybe there's no 4 here now.
By making hidden trial method, we will factorize it.
No. See, what is common here? X is common, so just take out x common. So this will become x cube by
Yes, sir.
yeah.
Hello.
So what you would have done is you could have just take out x common from here, and you are left with what? X square or 4x plus 4. So now you see this, you obtain this graph. Now this is quadratic. You can factorize quadratic, and then you will get all the factors. So second component of these things is to do the graphing, and for doing the graphing, you must know the factors. Okay. I hope this is okay to all of you. Okay. Is this okay?
Yes, sir. Yes, sir.
Okay. So now tell me, if you have doubt in graphings, do not worry. I will take up another question and I'll make you understand.
Sir,
tell me if you have doubt here in this particular question, except graphing part. Yeah.
Sir, if n elements belong to, जैसे यहाँ पर 15 assignments से अगर वो नहीं दिया होगा तो कैसे करेंगे?
तो हो सकता है यहाँ पे अगर 25 दे दिया रहता तो then you would have listed all that elements up to 25.
25 मतलब ये दिया ही जाएगा ना?
हाँ, ये दिया ही जाएगा. Okay. So now we understood this. Okay. Are we okay with this?
Sir, I have a question. Let's say for the last part it is given minus x minus 15. Then how our graph will change?
For what? Like
for last root minus x minus 15 it is given.
If it is plus 15.
Yeah.
Okay. So we'll do that graphing part. Don't worry. We'll change it accordingly. So over here, no confusion with the questions. If you have doubt with the graphics, I know you have doubt. We'll do more questions. You will understand this. Okay.
How did you conclude 11? Even 9 could be the answer.
How?
It is given equal to or greater than 40. That's why.
Here. We are telling it should be more than 40 and above, 40 or above, right? So if he scores even 40, then he passes. Okay. Any doubt? No doubt?
No, no, understood.
You understood, right?
Yeah, I substitute that
Yes,
letter
sir.
to get the answer.
Yes, sir.
Now go with the next part.
Hello, sir.
Yeah.
Hello, sir. I have a doubt in graded assignment 4.
Okay. You have to wait then.
Okay. Thank you.
Yeah. I was asking if you had doubt on that particular sheet. So no doubt there.
The
So that's
second
okay.
option is correct.
Now you see there is another question and this involves these things. Is it 1-1? Second option is correct. Okay. Any other?
Wait, sir, doing.
Okay, do it. All right. So now you see this, a polynomial is given. All right. So over here, it's clearly it says what you have to do is just do the graph for this. Okay. Now quickly, there were 2 steps, just 2 steps, right? What is step number 1? What is the degree of polynomial? Could you tell me what is degree of p of x?
10, sir.
10,
10, sir.
3,
So 10.
Let's
10.
count. 1
equals to 5,
plus
6,
2 plus 2, it's
7,
become 5,
10.
6, 7, 8,
10.
9, 10. So
10.
what is the
Yeah.
degree? 10.
10, sir.
even.
Okay. So this is again even. We should have actually made it odd. I'll do one odd also, don't worry. So, okay, so this is 10. And what is the leading coefficient? Is it positive, negative?
Negative.
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 Downwards.
So can I say something about my endings? It will be on the same side, like this.
Downward, same side.
This
Yes, sir.
up to here, this is okay to all of you, right?
Huh.
So these 2 steps,
Yes,
I can
sir.
make sure that this is happening. Had it been 11, what you could tell?
It will be odd. Then.
Okay, so I'm
It
just
will be
telling you,
again
had
needs
it
to
been
be
11,
determined.
will it be this side? Oh, sorry, will it be this way?
No, other way, sir. I
After
think
that.
other way.
Other way around.
The other way around. It's
Yeah,
going to be
this
like
way.
this. Okay.
Because
hope you are
leading
okay.
leading coefficient is negative.
Coefficient is negative.
Yes, exactly. So you got, some of you got it. Okay. So now this is, we know that this is 10, and did anybody did not get that?
No, I didn't
See,
get
this
that.
is
Yes, sir. Please explain, sir.
okay. So you should tell, no, then you shouldn't be quiet because you're writing it now. I mean, you should ask questions. Those who understood, that's okay. If you did not understood, you tell me you did not understood. We'll help you out here. Okay. So now you see this.
Sir,
You were knowing that
SSE question.
SSC questions, I'll take up one question and explain you. So x cube is something like this, right? What is the
Yes,
leading
sir.
coefficient over here?
Positive.
Positive. What about minus x cube? It's going to be
Negative.
this way.
Negative.
Downside.
So the whole concept we were building with this graph was when this is even and odd, right? So
Yes.
the earlier problem when we were doing it, I was telling you x square and positive. And I was telling you the endings are on this end side. But when you have complex equations, all what we were doing was, we don't know what is happening inside, but we are very sure about the endings, right? When it was even degree. What about when it is an odd degree? Odd degree, again, this endings we are just talking about, but we are not sure what is happening inside, right? That is something we get from the each roots. So now if it is x cube, how do you get it? So now when you say this, it is x cube. So either you can have it this way, or you can have it this way, right?
Yes, sir.
So
Understood.
two ways positive. So now you understand this. When it is positive, you were seeing that this was happening like this, something like this, right?
Yes, sir. Yes, sir.
Right. And when it is negative, it must happen something like this. So you see, I was telling you when this was 11 and negative, then certainly it would have gone like this. That is why they were able to tell it in that. Okay.
So can you please scroll up a little bit?
Scroll up.
I mean, I want to see the
Question.
equation.
Okay. Okay.
Hello.
Hello.
Yeah, it's better. Yeah.
Yes, sir.
Okay. One question. How is the degree of it p of x 10? I mean, I'm only able to
Okay, you're not able
get
to understand
9.
this.
No.
Okay. Now you tell me what is the degree of this one? 1?
Yep.
When you expand this, what you will get the degree? what it will have when you expand this? It will be 2.
Sir.
This will have
Okay.
1, this will have 1, this will have 1, this will have 2. When you expand this term, the leading coefficient is x square, it will have a degree 2. Now what? In turn, you are multiplying them all, right?
Sir, x
Now you're
minus
multiplying
3
this.
would be also 2, right?
Oh yeah, this one.
Yeah.
Right. So what are you doing now? You will be multiplying all of these. So it will become what? X to the power of 1 plus 2 plus 2 plus 1 plus 1. Over here also it's 1.
Okay,
Like
okay.
that.
Sorry, I missed
And when you
that middle x. Sorry.
yeah. So when you add them all, you get that degree. Okay.
I was able to get till the 9, but I was not able to find
Oh,
the
no problem.
next. Okay,
No
that's
problem. No problem. So now let's come to our graphing part. Now its degree is 10 and it is negative and it's going to be something like this. This thing we are convinced now. With these two informations, I can say that this, no. So how is that going to be? It's going to be something like this. It will be downwards. How? Because this is negative. Clear? Any doubt till here? No doubt?
No,
Can I
sir.
proceed?
No doubt, sir.
No, sir.
Okay, so if I can proceed here, let's go with this. So now you see this. Now what? I don't know what are its roots, right? So over here the roots are given. Now I'm done with this. Okay, now I don't have to deal with this anymore. Now I'm just dealing with the inner factors. Now what are the roots given to me? This is 1. From here I'll get x equals to 1. At x equals to 1, this will become 0, right? At x equals to 1. From here I'll see that x equals to 2, this becomes 0. Over here I see that at x equals to 3 it becomes 0. Similarly x equals to 4 it becomes 0. Over here at x equals to 0 it becomes 0. Over here x equals to minus 1 it becomes 0. And over here x equals to minus 2 it becomes 0. So this is the least value of x that I can have, and the most value that I can have is what? 4.
okay. So can I interrupt, please?
Yes, please.
Okay. Why we don't need to worry about the minus 0.01? I mean, what is its purpose? Or I mean, just
This is just telling you that what is the leading coefficient, negative or positive. See, this
okay.
is something
Okay.
or what,
Thank you.
or let it be like 1 lakh value over here. Okay.
Yeah.
This will just stretch this graph, that's all. But this, its characteristics will remain the same. The roots will remain same, right?
Okay.
The turning will
After that,
remain. Yeah.
after knowing the leading coefficient, we don't need much.
Yeah.
It
It's
means
just
that it tells a graph is upwards or downwards.
downwards, or like which
Yep.
side it is going. Yeah, it's just the
Okay,
characteristic.
I got it.
Yeah. All right. So now we know that much. Now what about the other things
Sir?
that we have to understand? Yes.
Sir, I have one doubt. Like for example, like if there is one function like x square minus 2 by whole square. So how to represent this function in a graph, sir? Like when it comes, like when we get a power on that x.
You can do like
in
this.
that part. Oh, okay, sir.
Right. You can do this, right?
Okay, sir.
All right. So you can just manipulate something there. So now what? Now I have taken out the extreme roots and I have written it here. Note my words. I'm telling extreme roots value, right? And now I'm left with what? Now the next least value is minus 1. Then comes 0. Then comes what? 1, 2, 3. Clear? Now what are we doing here is we just have to plot this graph. Now for each roots we will have to see, right? Now I'll just erase this part now. Now at minus 2, what is its multiplicity? It's 2. What is happening? If 2 means it will bounce back. Because I have to make sure that they are on the same side, right? At 1, what is happening? At minus 1, what is happening? It's just crossing. At 0, again, the degree is 1, so it will cross just like that. It just crosses like that. At 1, what is again the same thing? It crosses like this. At 2, what is happening?
Bounce back.
Bounce back.
Bounce back.
Go like this. Okay, it will bounce
3
back.
also.
3 also, it will bounce back, so it will go something like this. And then 4, it is going in the linear, right? So this is what the graph will look like. Okay, so now we understood the graph for this. Now let's come to
Just
the question.
I need clarification. What is the rules for this bouncing back and going down?
Yes, you see, the rule is very simple. If it is square, then it will bounce back. It's basically the endings has to be on the same side, right? See, look at this. Over here it is being square. That means the ending, if it is on this side, then it must come this way, right? You understood? When it is x square, when it is an even degree, it's a parabola. So parabola, it has to come back, right? Because the one ending is here, so the other ending should be that side. I hope
Hello,
that's okay.
sir.
Yeah.
Add the minus point, -1. माइनस तो सर अगर वहां पर बाउंस बैक हो रहा है तो सर नीचे होगा कि ऊपर होगा, ये कैसे पता चलेगा? ये नहीं आ रहा।
-1 पे बाउंस बैक नहीं हो रहा है।
नहीं, जैसे कि अगर कोई भी अगर आप जैसे पॉइंट लेते हैं, जैसे
suppose you take this 2, let's say this 2, okay? So now what was happening is, look at this. At 1 it was crossing in a linear fashion, okay? At 2 you know that it is going to bounce back, but where is your ending here? It's on the positive side, so it will come back and it will go. Okay, it goes like that. Over 3 again, it was again going to this side, but you saw that the endings are on the positive side. Then again from 3 it has to turn back, right? So that's how you'll understand. Yes, it has to bounce back like that. Clear?
Okay, sir. Okay. Yes, sir.
So having known this much, we can draw the graph for this, right? So now after drawing the graph, now you see this, look at the question part. So there is no problem with the graph. You can do the graph now.
Yes, sir.
Yes, sir.
Just do the practice. No matter how much example I give, it's useless until or unless you do the practice.
Hello, sir. Can you please explain end behavior, why it is going positive to positive and negative to positive? Please shortly.
Negative to positive. This one, the ending thing.
No, sir. It was.
He's asking end behavior.
Yes,
end
sir.
behavior. Okay, so when you go to minus infinity and positive infinity, is it that you are asking? When x goes to
about even and odd degrees.
Yes,
how
sir.
graph behave.
Why it is going negative to positive and positive to positive?
There is crossing value, here.
Crossing values. I think you are asking for end behavior.
Yes,
What
sir.
will
Yes,
be the
sir.
end behavior?
Yes, yes.
So end behavior is very simple here. Now what happens when x goes to infinity? What happens to your p of x value?
It is negative, sir.
It is going to be more negative value.
Yes, sir.
And what happens when x goes to, let's say, minus infinity? What happens to your p of x value? It's going to be more negative. So that's your end behavior. Okay.
Yes, sir.
Okay. So now let's come to this. P of x is 1, 1. Sorry, somebody told me this. P of x is 1, 1 when x is in this. So minus infinity to 2. There is minus infinity somewhere here and plus infinity somewhere here. Okay. So minus infinity to 2. There is no more bending happening here, right? There is no more bending happening. It's just going.
Horizontal line test.
Yeah, it's just decreasing more, right? Or basically not decreasing, it's increasing. I mean, it goes like this. Let's not say increasing, decreasing. Some of you might get confused. So, so you see what is happening here is this will keep on going, right? So from minus infinity to 2, there is no bending happening, right? So if I have to do the horizontal line test, what is that I'm getting? It passes at every point from minus infinity to 2. So it is 1 to 1 in this region. Certainly, yes.
4 to infinity v.
Now, when you go to 4 to infinity, again, the same condition is happening. So in this region, it is 1, 1 function.
Third one is also correct.
1, 1 function means for one single input, you are getting one single output. Simple. Clear? So that is something we got to know. Now,
Can you repeat it, please?
Third one is also.
Okay, so what 1, 1 function is for a single input of x, you get a single output. Okay. That is
So
1, 1 function.
Can you please give an example for when you give one input and get multiple outputs?
I'll come to this. Okay, I'll come to this. Now look at this. One input is nothing but this x values. Input is your x values, output is your f of x value. Clear? When you give x 1, what do you get yours? you get f of x1.
Yes.
This is one particular output you're getting. When you take x2, you get again unique f of x2.
Yes.
Right. When you take another x3, you get unique f of x3.
Yes.
So from minus infinity to minus 2, you see this you for a single input x value, like when you give a x value, you're getting unique output f of x value. Now I'll tell you where it is not happening. Okay. Now you see this region. Come to this part. Okay.
Okay.
Now let's say this is x1 and x2. And let's say this value is something 5. What is happening at f of x1? What is the value? 5?
Yes.
2 outputs are there.
What is happening at f of x2? Again 5.
So inputs are different, but the output is
Same
the
output.
same.
So there is no unique output.
Yes, yes, yes. Okay.
Right.
Thank you.
Thank you, sir.
You're welcome. So now we understood
Sir,
that.
Third one is also correct.
Please go ahead.
In this first option, if it is 2 minus 2 is included, minus 2 and 4 are included, then it is not one-to-one function.
Function. It's not 1-1 function. It's just because in that case, f of 2 is 0 and f of minus 2 is 0
Minus
and
2 is 0.
and f
4
of
is
4 is also 0. This will violate the condition of 1-1. I must have unique output for unique input. Right?
Sir,
yeah.
then option 1 is true or not?
Option 1 is true.
But
Option
sir,
3 is also true.
why? Because
Actually,
it,
no, wait. This is not right. This is wrong. Why? Because you take any particular value, if this is x1 and let's say this is x2. Right.
Yes, sir.
If you're doing
Yes,
this,
sir.
hello?
Yes, sir.
Yes, sir.
So what is happening? Okay, you know that horizontal line test, right? So what do you do? So when you do that horizontal line test, it'll intersect at 2 different places.
Yes.
Sir, if ending of the graph is upper side, then it is possible.
Still, it won't be possible. There also it will fail.
Sir, first option is incorrect.
First option is wrong. Incorrect.
Sir, if
Sir,
they
why?
give in the place of x, if they give y, is it right?
Sorry?
In the place of x, if they have mentioned y, like y-axis.
In place of x.
Yeah.
No, they will never ask you y-axis. They will never ask you like that. Now you see this, why this is failing is, now you see most of the time you would have seen a graph was going like this, and then if I tell you if this is -2 and this is 4, then you see here it passes the horizontal line test. You're getting my point?
Yes.
But over here it will fail the horizontal line test. It will intersect at 2 different places.
सर ये फेल इसलिए हो रहा है ना क्योंकि आउटपुट सेम मिल रहे हैं.
हाँ, आउटपुट सेम मिल रहे हैं because you see
मतलब -2 से 4 के बीच में आउटपुट सेम मिलेंगे ना.
देखो यहाँ पे
Please,
I'll tell you again. Yeah, I'll do that again. So you see this. This is a horizontal line I'm doing, and I'm telling that my function is defined from this to this region. That means I'm taking only this part.
Yes,
I'm taking
sir.
only this part, and I'm least bothered about what is there inside this region. But I'm worried about this. Okay. Now you notice this. This is some output value. No? Let's say this value was 5. Sorry, -5. But you are getting -5 for 2 different values of x.
Yes, sir.
Yes, sir.
That is why it fails the horizontal line.
Yes.
Okay, sir. Please, just one confusion. Isn't it x comma y, like minus infinity is x and -2 is y, or is it x comma x?
Could you come again? Sorry.
Okay, so the first is option px is a one-on-one function. When the first option is minus infinity comma 2 -2, right? Okay, so is it in x comma x, comparison type, or is it x comma y? Like, okay, I know.
I got it. Where you are getting wrong there.
Because
this is not coordinates. This is not coordinates.
Yep. That's what I'm asking.
Yeah, this is not coordinates. This is not x and y.
It's just x.
Range, like
Comparison.
Exactly. It's just you see this x in it says no.
Okay,
X,
so
these are
it's
the set of x values.
Okay, okay.
They
So
are
it's
not
just
coordinates.
comparison like x comma x.
Sir, I can say this is like as a range.
No. These are not the range. This is just the x value, the domain, restricting domain. You are restricting the domain. Now tell me, if only this was given, is this 1 function?
Yes, sir.
Yes, sir.
Yes.
Yes. In that case, it would be 1 function. Now,
Sir, excuse me, sir. Sir, if in this function px, it's minus 0.01 is not there in the equation. Suppose there's a question. So
Minus?
this point minus 0.01 is not there in the equation. Suppose.
Okay, this one is not given. Okay.
Not there, yeah. So this point would be true. Px1 function, when x is an element of this function would be true.
No, it will be false still.
No.
Still the same, right?
It will be false. Why? Because you see, what is happening is when these endings are on the same side, no?
Same side, right?
And when I give you this interval, something like this will always fail the horizontal line test.
And if I mean just like,
and if it
she
is an
said,
odd degree, and if I give you this interval, then it is going to pass the horizontal line test.
Okay, so just like she said, I mean, if minus 0.01 is not given, I mean, we can just assume it's positive.
Plus one. Then you have to
Okay,
assume
it's
it's
just
plus
plus
1.
one. Yes.
I'm getting confused once here. Like, how did you arrive with those values -2, -1, 0? Can you explain me once?
Which one? This one?
No. Yes. So you have drawn axis, right? X-axis. So you got the values -2, -1, 0, 1, 2.
How did I get these values?
Just explain once.
Okay. So these values is something I'm getting from here. These factors. See, what I'm trying to say is, if this is your P of x, for what value of P of x is becoming 0? For what value of x, P of x is 0? At x equals to, when x is 1, your P of x is 0, right?
Yes.
Likewise, when x is 2, it will be 0.
Yes.
At 3, it will be 0. At 4, it will be 0. So that's how I got these. Okay. So now let's go with the next option. How many turning points it has? 1,
9.
2, 3, 4, 5, 6, 7, 8. I have 8.
-2.
And here 9. Okay, so somebody told in the very beginning the answer is 9. Who was it? Person left already, is it? Okay, so no problem. So P of x is strictly decreasing when x is in 4 to infinity. 4 to infinity, strictly decreasing is the right option. Okay. Yes. Yeah, I'll come to this. There are exactly 9 points on P of x where the slope of the tangent can be
true.
Now that is also true because at this point the slope will be 0.
Sir, can you mute please centrally, sir?
Yeah, sure. So you see, at these many places the slope will be 0. So this also is correct. Okay.
Sir,
so now
please explain last point.
This one, the last one.
Yes, sir. Yes.
This means, see, where the slope can be 0 at the turning points. So how many turning points do we have?
Okay.
9 turning points. See, at this the slope will be something like this. At this the slope will be something like this, right? The slope will be 0 at this point, isn't it?
Yes.
So the total number of turning points will actually give you the total number of places where the slope becomes 0. Okay.
But
please
sir,
count the turning points. How we got the line? Which are the turning
points? So turning points are these. Wherever these bendings are happening,
okay.
right?
1, 2, 3.
Over here also the bending is happening. Over here. Okay. Now quickly, I'm not doing anything more, but had it been this as degree 3, how will the graph be?
Hello, sir. Tangent can be 0 is nothing. I can confuse this.
And negative.
Tangent can be 0.
ये confusion look कैसे 0 हो रहा है?
अच्छा, tell me, if this is your curve at this point, what will be the tangent? Will it be something like this? I'll mute all. what will be your, this is your tangent, right? It is parallel to your x-axis. Understood?
Yes.
Okay. Okay. So now quickly for this particular question, I was telling if it is x cube, how will the graph look like? What is the degree of p of x?
11.
11. Okay. Now could you tell me this is negative, so how will the endings be?
Sir,
This way?
no, sir.
No, sir.
Opposite way.
Opposite way. So opposite way means something like this.
Yes, sir. Left to right.
Okay. So now what are the roots for me? Now these two steps was just essential for knowing this. Now I'm going to do the graph for this part. Okay. When it is x cube. Now what is happening? So again, my roots are -2, -1, 0. Then I have 1, 2, and 3. Right? So now how will this turning happens? That is something we'll understand. Okay. Now
So 4 is also
Sir,
there.
4 is also there.
4, yeah, 4 also is there. So 1, 2, 3, and let's say this is 4. So now let's do the graph for this. Okay. So now you see this at -2, what is happening? It's x cube. How does the graph look like for x cube? Can you tell me?
Will cross, sir.
It's crosses, but slight bending, right? So though the endings will be there like that, it won't cross in a linear fashion, but it will go like this. Right?
Yes, sir.
It will not go in a linear fashion, but it will have some slight bending and then it will go. Right? Now, can you tell me at -1 what is
Bounce
happening?
back.
At -1, it
No,
will
sir.
not.
Linearly it
No,
will
sir,
cross.
it will not
Yeah, like
bounce.
that.
It
Yeah,
will
I
cross
was saying
it.
like cross
At
like
0, it go
It
like
will
this.
cross.
At
Yes.
1, it will go like this.
सर बट -2 में भी तो ऐसा मतलब समझ में तो यही आ रहा है ना कि बाउंस बैक हुआ है
-2 पे?
यस सर
On positive 2
Not
is saying
minus
that
2
positive
x
2.
square.
Bounce back तो नहीं हुआ है, क्रॉस हुआ है. You
it
see,
is not said bounce. It is
लीनियर
said
बोल सकते हैं बट बाउंस बैक नहीं.
bounce back is it's going on the same side.
यस सर ठीक.
Okay. Now what is happening at 2? It's quadratic.
It's
So
quadratic,
see,
so
one
it
of its
will
ending is
bounce
on the
back.
positive side, so it will go back again. At 3 again, it is quadratic, so it will go back again like this. And at 4, what is happening? It's in the linear fashion, so it goes like this. Now you see this. Now if I tell you, now is this 1, 1 in this domain?
Which domain, sir?
In this
Yes,
domain?
sir.
Yes sir.
Yes, it is. Because now
Yes,
you
it
can draw
is.
the horizontal line test. It will pass there. Okay. And
Yes,
number
sir.
of turning points. How many number of turning points do you have? 1, 2, 3, 4, 5, 6, 7.
8.
Number of turning points will be 8 in that case.
8.
And P of X is strictly decreasing in this thing, 4 to
4
8.
to infinity, yes.
4 to
Yes,
infinity,
sir.
yes, that is still happening. So this is also right. Forget about this for time being.
Yes, sir.
That you will learn more in the week 7.
Mm.
Okay.
Px
So now,
is 1 function when x belongs to minus infinity.
Sir,
okay, so
So
now this
how
is
having
all
one
the
It's a
doubt.
1-1 function. Now it's a 1-1
Hello.
function.
Yes, please go ahead. Now,
First,
I
first
think
graph,
okay, just
the
let me
graph.
finish this. Now we are done with all the week contents.
So just one doubt.
Hmm.
The graph, the starting point of graph started on positive axis and ending was the negative.
Hmm.
So why is it only positive it started?
Yeah, it's because of end behavior. So how is that we were knowing was, I was telling you with this x cube graph is something like this, right? And
Yes.
minus x cube graph was something like this, right? So I
Yes.
know that when it is negative coefficient and if it is an odd degree, then it will cross in this fashion. That's how I got to know.
Can we ask our doubt now?
Yes, now you can ask it out. Now
So
I'm
in
done.
what-
Officially,
so
it's like done and you can leave the session. And see, I just want to give you some input. So just listen to it. Then you can ask your doubts. So you see this, basically like whatever we have discussed till here, this is more than enough for you to pass your exams with good score. Okay. So you can just practice this question. I mean, at least similar type of questions you can expect. You can practice these questions multiple times, right? Do remember that graphing is very, very important. If you cannot do the graph, then you are done. You will fail. Definitely you will fail. Understand this. Okay. So
Please.
because you're
Nothing. Just we already failed. That's why we're here.
that's
So
why I'm telling
please.
you that Yeah, I shouldn't be telling that, but I want you to be more cautious. That's why I'm
Yeah,
telling you
yeah,
that
yeah.
negative thing.
Correct. Just
I
kidding.
shouldn't be telling you that negatively, but
No.
that is very much important that you should understand graphs. See, I think this is something a criteria input. If you don't know graphings, you cannot come for maths one, because afterwards when you go, it's all about graphs. It's all about this. Now it's polynomial, then you will learn exponential graph, logarithm, then compositions of functions graph. Then you have calculus, where again it's involved graphings.
Yep. Okay, so someone said in the beginning that can we please solve the qualifiers exam paper question
Sir,
paper.
I have doubt. I have a
It's
doubt,
already
sir.
provided to you
Sir,
actually.
please solve our doubt first.
Sir,
Sir,
doubt,
Okay,
sir,
let me
please.
finish. Let me just give
doubt.
me let me just give you the things which I have to tell you.
Okay,
Hello,
sir.
sir.
Okay, okay, okay.
Then I can
In
take
this
up
sum
doubts.
only, if the
Hey,
first
sir,
point P
sir,
of X is
Let the sir speak, now.
let sir speak.
Let me finish it.
Everyone, please.
Then you can ask the things, right? So you
Yes.
see that you understood that graphing is, I have written it in the very beginning that what is its portions, and you would have understood that yes, the graphing is very important. If you are thorough with it, it's perfectly fine. You will definitely pass with a good score. Likewise, the questions which I have discussed here, it's very important. Do solve them. Solve it 4 or 5 times. Okay, do that. At least if you get a similar questions, you'll be able to attempt, right? You can do that, isn't it? So do this part. And thirdly, your mock papers, the mock paper which was given to you, do solve that mock paper, practice it. And if you are thinking like you can get some question of your quiz which was asked, we will certainly keep it different, right? So we will never give a questions which is similar as in the quiz. So if you are breaking your much head into that thing, do not do that. But of course, learning is something I will really appreciate. We'll discuss that part. It's okay. But what I want to say you essentially is whatever we have done today and your mock is very, very important. Do them, practice them. Okay. So this is all from my end. Those who want to leave can leave, and those who have doubt can stay here. Yes.
सर
in mock,
सर जो
in mock test. I have doubt in mock test.
क्वालिफायर हुआ था सर उसी की जैसे सेम क्वेश्चंस आएंगे ना?
Yeah, the previous on Jan 27, the same session has been held by Vicky sir, and the same question has been given. We got to found in our qualifier Jan 30. I have matched them.
No, I said that in this qualifier also the same pattern or same
That
type
depends.
of question.
That depends to IIT. That depends.
विक्की सर ही पेपर बनाते हैं लगता
Sir, I have doubt in mock.
But yes, we'll hope that this sir is telling. So these questions will be.
Yeah.
Sir, if we do all the courses and the tutorials, will I be able to qualify the qualifier?
I'll tell you one thing: if you just solve this thing, what we have done, and you are thorough with this, you'll pass the qualifier. Could you tell me like what the previous live session we had
one
taken?
function? Please explain it one function once again, sir. The last
sir,
one.
sir, one function. What is one function, sir?
Sir, I have doubt, sir.
Sir, firstly,
Sir, from graph, they will ask us to form the
Sir,
equation,
sir.
sir.
Excuse me, sir.
sir,
Hello.
So officially we are done. Okay. If you want to do more with the graphing parts, I will tell you that go watch your previous live session.
So first
videos.
clear our doubts, na sir.
Okay, I'll tell you one thing. I want to
Sir,
tell you.
they
Wait,
ask us
whatever
to
doubts
form
you
the
have.
equation, sir.
See, if
Someone
all of you ask, just let me speak. No, I'll tell you what all things you can do. If you have doubts in your graphing parts, do watch this week 4 videos what we have taken it. At least you can go watch my videos only. Like
Sir, where can we watch that?
you will find it in your
I've shared the
live
link
session.
of the video.
Live session links what you had initially, right? You can just go watch that video again. It's recorded. It's recorded in the YouTube.
Except of
I
this.
have doubt in mock test.
Okay, let me finish, yaar. Let me do it. Let me speak once.
sir,
So week 4, that graphing thing is important. You can watch my previous videos. That is essential. For week 1, I have also taken the very first live session. You have the link in your portal. You can go watch them if you have doubt.
Sir,
So
can you
do
tell
this.
me where exactly the link will be in the
But
portal?
telling about the tutorial, na week tutorial, you need to watch the week tutorials, right?
Yeah,
Tutorial is
tutorials I have watched all. That's what I am asking. If I have watched all the tutorials, will I be able to qualify the qualifier round? Because mock test is very
Okay, I'll tell you
difficult
one
for
thing.
me.
If you watch the all qualifier, but you do not solve these questions, you will not be able to qualify your exam.
No, sir. I am solving the mock questions and they are very difficult. That's why I was asking.
So you can solve the mock questions. You can solve this today's live session, whatever the questions we have told. This will certainly help you to pass your exams. And also, if you want, you can watch this tutorial videos. That will help you.
Sir, we didn't discuss SSC problem.
Yeah, we didn't discuss
So-
that because I thought this was given
So
in the box.
in this question, can some option can come like a one-on-one function?
Definitely it will come.
So can you show in graph how to identify one-on-one function for the first option?
Yeah, I think so many people you asked me what is one function. How do we identify this? Okay. Now
Sir,
you
firstly,
No,
sir,
one
firstly, discuss the strictly decreasing, increasing. Sir, this is something confusion.
Okay. Okay, fine. We can discuss that as well.
Yes, sir.
But I have a general doubt regarding the exam. Hello.
So just give me a minute. Maybe I'll take one graph and then explain you that part. And then I think I'll do now. See, I'll tell you what I'm going to do right now. I'm going to do this one function, and also I'm going to explain you what is this strictly increasing and decreasing thing. Okay. So stay with me, and if your doubt is done, so it's good. So now just pay attention with me. Okay. Then I'll take up the other doubts. If you ask me, all of you ask me doubts, I won't be able to clear any of your doubts. So now you see this. I will just do the graph. I assume now you can do the graph. Okay. Now just take this 2, 3, and 4. Okay. If this is my f of x, could you tell me, is this f of x one function?
Yes, sir. It is.
It is not. Okay. So why it is not? So I'll tell you, there is something called horizontal line test. Okay.
Sir, this is not a one function.
This is not
because
one function. I will tell you
between
why.
2 and 3. No.
Yes, sir. Horizontal line it crosses 2 points. 3
I'll tell you
points.
this. Let me
Yeah,
finish
it
this
got this 3
horizontal line
points.
test.
Okay. 3 points.
What is this horizontal line test? Okay. What does this tells you is, all you have to do is just draw a horizontal line. But you will be doing this only when you have a graph. What you will do is you do the horizontal line parallel to okay, now you can see this, right? Horizontal line parallel to x-axis, and then you make the conclusions. Now you see this is your x-axis, right? So what does it tells is, if your horizontal line touches the curve, okay, so maybe I should tell it in another ways. A horizontal line passes, okay, a horizontal line passes, let me say this, horizontal line test passes the horizontal line test when the curve f of x, when it touches the curve at most at one point, sorry, or let me not say at most, when it touches the curve at, let's say at
exactly 1 point.
yeah, touches the curve exactly at 1 point. If this is happening, if it passes, if this test passes, then it is 1 If it fails, then it is not 1 Am I clear? Now what is this horizontal line? Horizontal line is a curve is given to you. Okay, then what do you do with that? I'll take some different color maybe. What I do is I take any horizontal line. I have a freedom to take any horizontal line. I'm taking this horizontal line. Okay, can you tell me this horizontal line touches this curve at how many places?
3.
1, 2, and 3. These are the 3 places where it touches. Does it passes the horizontal line test or fails?
Fails.
Because what does it is? Horizontal line passes the horizontal line test when it touches the curve exactly at one point. How many? Exactly at one point. But it is touching at 3 points, so it fails the horizontal line test. Now you see this. Come to this part. Now what I'm trying to say is, okay, so now you see this. Sorry, I just lost it for a while. So now what? Now I'm saying, now I'm restricting my domain. Okay, when x is in 4 to 3 to 4, is it 1 1?
No. No, sir. No, sir.
No, sir.
Okay, so could you tell me when x is in 3 to 4, what happens? So what you will do, you will again do the horizontal line, but what you will do, you will do it in this interval. Now if I take this interval, this is my interval, the horizontal line. You see my horizontal line is not extending beyond that. It's in between this interval, right?
Yes.
How many places it touches? 2 places. It fails the horizontal line test again. So it's not 1 1 again. Clear?
Yeah.
Now we'll go to the other thing. Now let's say when x belongs to 4 to, let's say 4 to 5. No, let's not give it 5. 4 to infinity. What happens?
Yeah, it is 1 1.
1 1.
Let me include 4 also. What is this? Is it still 1 1? Yes.
No.
What I'll do is,
Yes, sir.
why no? You take any point. You take, so you took this horizontal line, but you have to take from 4. So you, let's say you go like this. How many places it touches? 1. You draw any horizontal line test, you do any horizontal line, it'll just touch at once. So it passes the horizontal line test, right? So in this interval, it passes the horizontal line test. Now tell me, in this interval, could you tell me, does it passes the horizontal line?
Yes, sir.
Yes, sir.
This too. Does it passes?
Yes, sir.
Yes,
Again,
yes.
again, at maximum 1 it touches, right? Could you tell me in this, does this passes?
4 in infinity.
Yes.
No.
Yes. I will do what? I'll just do horizontal line over here, right? These are the only thing, no? And then I'll be drawing here. It passes. Right? It passes. Any confusion here? No. Shouldn't be.
No, this is 4 in infinity.
What you will be doing is, you will be doing horizontal line test. Now minus infinity is somewhere here and 2 is here, right? So this is something like this. You're just drawing a horizontal line. So just take one horizontal line, right?
Got it. Got it.
So this horizontal line will be extended this side as well, because it says, no, your x is from minus infinity to 2 and then 4 to infinity. So this is that horizontal line which goes. It cannot be here, this line, isn't it? So in this line, how many places it touches this curve? 1. Right?
Yeah.
Now I can take any other point. Let me say I'm over here. Now if I have to draw the curve, now again I'm doing the horizontal line test, but I have to make sure that I'm in this itself, right? So if this is the case, then yes, up to 2 I'll draw the horizontal, and of course from here, right? Does it passes the horizontal now? Yes, no?
Yes, sir.
It passes. Similarly, when I have to say that when x is 4, let's say it was somewhere here, then again I'll have to make sure that I have this curve till 2 as well. Does it passes the horizontal line test? Yes, it passes. It touches at one place, that's all. It does not touches elsewhere, right? Is it okay?
Yes,
हेलो सर सर मेरा डाउट ये है कि जो आपने x से माइनस इन्फिनिटी कॉमा 2 एंड यूनियन 4 कॉमा इन्फिनिटी लिया था, उसमें 2 से लेकर 4 के जो कोऑर्डिनेट्स है वो इंक्लूड हो रहे हैं कि नहीं हो रहे हैं?
उसमें तो इंक्लूड नहीं किया था मैंने.
माइनस
सर ये डाउट था मेरा एक्चुअली कैसे.
तो अच्छा, आपका ये डाउट है तो मैं आपको बताता हूँ. You see this, when x belongs to this, let's say, sorry, when x is minus infinity to 2. This is some critical doubt. एक अच्छा doubt भी है ये. So now you see this. I'm not including at first, okay? When say I'm not including it, then what is happening? This is the case, right? I'm not including 2 and 4. When I'm not including, certainly it is passing the horizontal line test in this given restricted domain, correct?
Yes, sir.
But what happens when I include them? Minus infinity and 2 union. Now I'm including them, right? 2 and 4 to infinity. Now you see this, if I draw a horizontal line at what? At x equals to 0. So if I have to draw a horizontal line from here and horizontal line from here, so this is what I'll get, no horizontal line, where 2 is included. 2 and 4 are included. What is the value at 2 you are getting?
0.
And what is the value at 4?
0.
That means it is touching at 2 different places.
It is not 1 to 1.
It is touching at 2 different places, here and here.
Yes, sir.
That way it fails the horizontal line test. Now tell me, if this was not there, 4 is not included. Then what happens? Though this is there from there, right? Now what is happening is, over here this curve goes like this. That means this point at 4 is not included, but except all that is included. So in that case, it passes the horizontal line test when this condition is there.
Sir, for the first case,
Also, sir,
that is
only minus to infinity is included, na? In this.
Minus infinity to?
2. 3 is not included.
3 is not included. You can see, no. Union, then it starts with 4 to infinity. Okay.
Sir, I am confused in union.
You are confused. I'll tell you, see what happens is, if I have to draw this union part, okay, if I have to draw this union part, how will I do is 2 to infinity, that means this is this place, and it says 4 to infinity means 4 to not included. 4 is not included, and it goes like this. So this is the line for this. Understood?
नो if x मतलब अगर मेरे को ये दिखाना है कि 2 से लेकर 4 तक मतलब मैंने लिया हुआ है x के एलिमेंट्स, तो वो कैसे शो करेंगे? 2 यूनियन 4.
अगर 2 से 4 का दिखाना है तो ऐसे क्या करना है? सिंपली ऐसे कर दो, 2 to 4, x belongs to 2 to 4 हो गया. उस केस में कैसा रहेगा? अगर उसको दिखाना होगा तो 2 to 4 is something like this.
सर ये तो ब्रैकेट पे डिपेंड करता है ना.
तो that is why this is open. अगर ये खुला है तो
नहीं, अगर एलिमेंट्स बिलोंग टू 2,4, इट्स मींस 2 and 4 और 2 to 4.
2 to 4.
Okay.
अच्छा, I get it. So you see, जब भी whenever we say like this, whenever we say this interval, no, ये पूरा values लेता है. जैसे कि पूरा values लेगा. Like from if I say 4 to let's say 100, it is taking 5, 6, 7, 8, 9, 10 up to 100.
Okay.
You got it?
100 is not included.
इसमें थोड़ा सा और confusion है. You represent your coordinates also like this, right? 4 to 100. अगर वो coordinates अगर रहेगा तो coordinates में you don't show that. Coordinates में क्या हो जाएगा? ये तुम्हारा एक point है जो कि 4,100 है. Coordinates में ये point है. But when you say x in this, that means your x belongs to this region. मतलब subset of x values. ठीक है? Got it?
Okay, sir.
Okay. Now let's go to that increasing, decreasing.
Case,
You don't have
to solve for the first case.
Sorry.
That is x belongs to minus infinity to 2 union.
Minus infinity to 2.
Okay, and then union 4 to infinity.
4 to infinity.
Here we will be excluding 2 and 4, right?
Right. So you see your bracket is open here, right? So this point will not be there, and let's say this is 4 and this is minus.
So will the function here will be 1, 1 or not?
It depends on function. Function to I have erased, right? If your function was like this, right? If this was your function, right? Then it is 1, 1.
Okay.
You tell me why it is 1, 1.
Sir, because we are excluding that part 2 and 4. So before that, means after 2, the curve is going down, so it will only cross 1 at the horizontal, means cross at one point at the with horizontal line test, and for 4 also the same will happen for the upper part.
Okay, you understood then. All right, now let's discuss this increasing, decreasing. Okay, now before
So
going there,
one
one more thing.
question.
Before going there, okay, when x is in minus infinity to 2 union 4 to infinity, is this 1 function?
No, sir.
No.
Why?
Because a horizontal line test is fail here.
So now you see this, when I have to draw this horizontal line in this interval, so I'll take any point. So I can only draw horizontal line between this, right? Now what happens? So if I have to draw this horizontal line, let's say I'm drawing this, so it will be similar here. Now it touches at 2 different places. It fails the horizontal line test, right? Clear?
Yes.
Okay, great. So now
So-
this is
Can you elaborate this? Can you elaborate this?
हेलो सर, हेलो, एक मिनट सर।
Yeah.
ये माइनस इन्फिनिटी आपने लिखा था, तो वो तो नीचे रहेगा ना उसका?
नहीं
बट इसको एक्सक्लूड कर देंगे ना।
नहीं what minus my graph was like this, something I'm telling like this, suppose, right? This tells you set of x values, it doesn't tell you f of x value.
Yes sir, but minus infinity is belong to lower part na.
But that's what I'm saying, no, ये तो x value है, ये f of x value थोड़ी है. This is not f of x value, this is x value. So this is your x value.
Okay.
Yeah, but this will touch only at one point.
Left side, right?
Minus infinity 2 will touch only at one point, and 4 and infinity will touch at one point. So,
Right.
Sir, discuss the strictly decreasing, increasing.
It will touch at one point, but this is union. You will have to take the sum.
It means that a minor infinity is showing that it is decreasing.
no, but in the earlier case, you ignore the union. You know, although it was
No,
in
I
union.
did not ignored it union. I was always drawing the graph like this. I was telling you, know, that this part I was drawing this line and I was drawing this horizontal line like that.
Yeah, so you ignored that union. You said that's separate.
No,
that's separate.
no, I was including it. When I included, then only I was able to draw this. You see this? Now I'll tell you, understand this. When it is minus infinity to 2 and 4 to infinity, this is what you get. Now, if I say I chop off this part, if that is not there, that is what, then I can only have horizontal line, which is of this, that's all.
Yeah.
Understood?
This part I understand. Yeah.
Okay.
So I have a question.
Okay, before going to that question, I just want to tell you that increasing, decreasing thing, so that I can finish up these two topics. Let's say it goes like this. Okay, so now you see that, notice this is happening what? Now tell me, is this function increasing from minus infinity to 2? When x is in there, is this increasing or decreasing?
Decreasing.
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 Minus.
When x is in minus infinity to 2, is this function f of x increasing or decreasing? Decreasing.
Minus
Increasing. Increasing.
That is increasing. That is increasing.
Or increasing, decreasing. Tell me. Is it
Increasing.
both?
Minus infinity to.
You see, what you have to do is, whenever you check this increasing and decreasing, you always come from left hand side to right hand side. Just keep it in your mind. Do not forget this rule. Whenever you check for the function, whether it is increasing or decreasing, you come from left hand side to right hand side. Left hand side is something like this. When x is, let's say, minus 4 and x is, let's say minus 2, what is happening to your f of x? Let's say this was minus 100 and let's say this was minus 10. As you come from left to right, this is what I mean. You go in this direction when you're checking for increasing or decreasing, right? When you're coming from left to right, what is happening to your function? Increasing or decreasing?
Increasing.
It's increasing.
Decreasing. The negative is decreasing.
Do not say negative and all. what is happening? Least
It's
negative, it's
Decreasing.
increasing or decreasing? Which is bigger? Can you tell me?
-2 is
-2 bigger.
Could you tell me? Okay, this is very fundamental question. Which is bigger?
so -2.
-10. Yeah.
I should be using this or this.
So line no bottom right.
-10 is less than -100 is less
minus
than
10 is greater.
-10 is certainly greater, right?
Minus
Yes,
10
sir.
is greater.
What is happening over here? This is greater value. This is not. This is greater value.
Increasing.
So it is increasing.
Yes, sir.
So what first rule is what? You come from left to right, right? You come from left to right. So when you go from left to right, what is happening to this function? Increasing or decreasing?
It's increasing.
Increasing, right? Now what is happening? Now understand this. You always come from left to right. Some of you start looking in this direction, which is not valid. Do not do that. I think that is what we're doing it right now. As I'm going to negative x, this value is what? Increasing.
Decreasing.
So there were so many confusions. So just follow this. You will always have to come from left to right, but what is happening to your f of x? Increasing, decreasing? Increasing. So keep that in your mind. What is happening from 4 to infinity?
So it's increasing.
Again increasing. This is very straightforward, right? As x increases, f of x increases. Over here also, as x increases, f of x increases. Now tell me in this region what is happening. If it was 2 and this was 3, what is happening between?
Sir, first increase.
When x is in 3 to 4, what is happening? Is it increasing, decreasing?
So increasing.
Between 3 to 4.
Increasing.
Sir, increasing and
decreasing. And decreasing.
Sir, increasing.
Overall, can I say it is increasing in this restricted domain?
Yes, sir, but sir, slope first increase and then decrease.
Forget about slope. Just look at this function. Tell me, in this interval, is this function overall in this interval, is it increasing?
Yes, sir, it's increasing.
It's increasing.
Decreasing, फिर increasing.
No, sir.
But my question is overall. This question is
increase, sir. Overall increases.
Is increases in x this thing. Is this a right statement?
So it's increasing.
Firstly decreasing, then increasing.
No, sir.
Okay. Just a minute. Now you see this. F of x is increasing in this is a wrong statement. Is it increasing? It's not just increasing. It's decreases then increases. But the question is f of x is increasing in this is a wrong statement. Why? Because it's not just increases, but it also decreases.
No, it increases and then decreases.
It decreases and then increases.
That is 3 and 4 are the coordinates.
This is not a coordinate. That's what I was telling you.
It's fx.
X in 3, 4. This is the set of x values.
Interval.
Do not get confused with coordinates and the set of x values.
Sir, 3 and 4 fx is not.
It is neither increasing nor decreasing in this interval 3, 4.
Yes, sir. Decreasing.
So when something, if it is asked, it is strictly
increasing, decreasing is just, sir, only on depend on interval, sir. Not in the fx, sir.
सर तो ये 3,4 का क्या होगा मतलब इन डिक्रीज इंक्रीज ना
हाँ बट ऐसा कुछ है ही नहीं. The question was whether this function is increasing. The answer is no.
Okay.
Is this function is decreasing? The answer is no. It is also increasing, right? In that interval. So you cannot say
increasing, decreasing depend on only interval, not fx. That's I'm right, sir.
Not what? F of x.
No, sir. I'm telling. Increasing, decreasing only on depends on interval, not fx.
It does depend on the interval.
Yes, sir. They only depend on interval, not fx. I can say.
Not fx. You have to consider fx. No, you cannot ignore fx. Fx is the one which you are checking whether it is increasing or decreasing in that interval.
Yes.
So it means the answers cannot be defined.
For?
So you go and apply this figure in the equation to get that.
Sir,
you see, you cannot ignore f of x. Your interval is just an indication that you have to look your f of x in that interval. You understood?
Yes, sir.
You cannot ignore f of x. Okay, so having known this, I think you can see this video again to see how does this
सर
increase.
एक डाउट था सर सर अभी आपने इससे पहले एक ग्राफ बनाया था माइनस इंफिनिटी टू 2, तो वो सर ऊपर से बनाया था आपने मतलब, और ये वाला नीचे से बनाया है, तो उसका मतलब सर वो नहीं आया समझ में।
उस पे भी बना लेते हैं, तो उसमें क्या समझना था?
सर
मतलब
लीडिंग
कि
कोएफिशिएंट को
माइनस
डिफाइन करता
इंफिनिटी का तो नीचे से बनेगा ना सर।
मैं समझ गया क्या प्रॉब्लम है। You see, जब भी whenever we write like this, minus infinity to 2, this is this set of x values. It's not f of x values.
Yes, sir.
There's nothing to do with your f of x. It just says that f of your x is in this. If I have to do this, this is something like this, minus, sorry, 2. Right.
Sir. Yes, sir.
Now your f of x could be increasing, decreasing, anything, right?
Yes,
I mean,
sir.
however
Yes,
it can have. Not necessarily your graph should go like this. Your graph can go like this also.
कैसे भी बना सकते हैं सर?
हाँ, this is, but
वो
what
डिपेंड
about
करेगा
this?
fx पे।
वो डिपेंड करेगा fx पे, right?
हाँ इसमें.
Okay, so I hope this is okay.
Yes, sir.
Okay, so now if
Yes,
this
sir.
is,
Sir,
now
I
I
have
have
a
cleared
doubt.
this doubt. Yes, tell me.
So, will onto function also be asked
Onto function, no,
in graph?
no.
If we want to identify in a graph, is there any way to
There is a way.
identify
There is a way.
onto? Can you show us, sir?
Sure, I'll tell you that. So first tell me, for onto it has to be what? 1, 1.
1, 1.
And then range should be equals to what?
Codomain.
Codomain. Or sorry, it's just this, right? Onto.
Yes.
Onto is range equals to codomain. So now if I tell you a graph is given to you something like this, okay, and I tell you, tell me is this an onto function? This data is insufficient. So what I'll tell you is this function f of x, let's say this is f of x, it's defined from, or maybe I cannot tell you this, I can give you something like this, and the vertex is -5, -4. Okay, and I tell you that this is my function f of x, okay, and this function is defined from, let's say this function is defined from -infinity to +infinity, or I can just simply say that it is defined from r to -4 to infinity. This is where I'm defining my function. So what does this tells you?
Real number.
No, not real number. But what does this tells you when we write it in this way? It tells you that this is your domain, right? And this tells you the codomain.
Okay.
Okay. Whenever we define a function like this, we mean that this is your domain and this is your codomain. So domain means what? The set of x values your function can take, and codomain is the set of y values that your function may or may not take. Codomain is something like that, right? Okay, this is okay. Now tell me.
onto वाला सर ये क्वालिफायर में आएगा क्या
अभी? I don't, तो मैंने डिस्कस किया नहीं था पहले तो नहीं आएगा रहता तो I would have definitely.
Sir, I have to leave. I have a small doubt from that time.
Just
like,
let me. Okay.
Yeah. Could you
If it
please
is
just
small doubt.
open the mock solution which have been given to us?
You stay with me, the other person. I'll just tell you what is that happening. Okay.
Okay, sir.
Yeah. Tell me. Yeah. What is your doubt in mock, and then you can leave.
In question number 8 solution. Oh, sorry, like 7-1. Yeah. That one only. Graph one. 8. Question number 8.
8.
Yeah. 8. So here it is like it's an odd degree polynomial, right? And it's having an negative as a coefficient. So it's starting from like it's starting from upward and going to the downward ending and term, right? But like one question which you have discussed, in that you have taken starting from downward and ended also downward, having the same coefficient negative, and at that was a negative degree.
Negative degree means what? Even or odd?
Odd degree, sorry.
It was even degree.
It was a odd degree, sir.
No. If it is on the same side, it will be even degree. Check that again.
Yes, sir. You just open that question, that graph question.
The one
but
which
for
I explained.
clarity, can you just explain this eighth question? This one. The
Which
graph of the
particular?
eighth function. Yes.
It's similar to what I discussed, right?
Similar to what you discussed in one
Yeah,
of the
it's very similar.
So
You can use this as a
small doubt is there, sir.
Tell me what is your
Yeah. That question, sir. Please open on that question, which you have discussed.
I think I have erased that.
Yeah, here.
See, what is the degree?
Even.
Even no. There was like another question also.
That is also even. You check it again.
Both are even.
Both
Even
are
means open on same side.
So
Okay,
it's a odd degree, sir. That question.
This one.
This one. Yeah.
Check. Check this quickly and tell me, is it odd or even?
5, 5, 6, 7, 8. Sorry, it's even.
Even 10 degrees 10.
10 degrees are even.
Now I understood where you are thinking. Maybe I have taken another example. I was telling you, what if it was degree 11, then I drew the graph in a different way. And
You
then...
made that last one
Yes.
3.
Yeah, that one only.
No, don't worry.
Sir, can you quickly take one of the question? I also have to go.
No, just let me finish first and then I'll take up yours. Now you can leave, right? You can go. Yes.
Yes.
Now what I was telling you here, this indicates domain and this represents codomain, right? So you see that what was the condition for onto? The range should be equals to codomain. Could you tell me what is the range for this f of x?
-4 to infinity.
And 4 is included?
Yes, sir. 4 is
Yes.
included.
Yes,
sir. Infinity not. Infinity is not included.
Now
Yes,
you see
it
this?
is in.
So now I can say that this is onto function, correct? Clear?
No, I'm yet not getting it.
Okay. Now you understood this is your range. This is your range, right? You only told?
Yes.
What is the definition for your onto? Range should be equals to codomain.
Yeah.
What is your codomain?
Codomain.
-4 to infinity. What is your range?
Same.
-4 to infinity. They are same. They are equal. So that is onto.
Can you give another example, please?
It's both have same.
Okay. So you see, whenever I draw the graph, when you ask me to explain me graphically, then this is something you will do. We will restrict the domain. We will restrict the functions. Okay. And then we'll tell you to find out domain onto function or not. Another example we can take it is something, let's say like this. Okay.
It's good.
And let's say this is 5 comma. Okay. Let's say this is, it goes this way. This is 5 comma -3 and this is 5 comma -8. Wait. Let's say this is -8, huh? And this goes to, this is your f of x, and I'm defining my function from R to, let's say okay, -8 to positive infinity, and -8 is included. Okay, now could you tell me what is the range for this function? Tell me range for this function. What is the least value this function can take?
It's
let's say this is -2. What is the least value this function is taking? Come on.
0, -2.
What is the range of f of x?
-8 to infinity.
Minus?
8, infinity.
No, tell me, the other person who asked me this question. Could you tell me what is the range for this function? Okay.
0
so range,
to
8. Range is nothing but set of x values. Sorry, set of y values, right?
Okay.
What is the least y value this function is taking?
-2.
-2 or -8.
Okay, yeah.
It is least, right?
Right, yes.
-8 to, sorry,
Minus
-8 to, and what is the maximum value this function can take? It's going to up to infinity, positive infinity, right? You see, both are going on the positive infinity side. -2, no, not -2. Look at these values. What is the highest value it is taking?
Okay, sir.
It goes up to infinity, right? Clear?
Yes, sir.
Yes.
Clear? You have doubt here.
Clear.
You have doubt still?
No, sir. Clear.
Not you, the person who asked.
Sir,
What's your name?
Sir Sneha.
Yeah,
Sir,
tell me, Sneha.
codomain and
See, Sneha, all you have to understand is for your onto function, the range should be equals to codomain, right? So range is something you will have to find out. Codomain is something which will be given to you. Understood? Range is something you will find out. So once you get the range, you will have to just map those two. If they are equal, then done. Okay.
Okay, so here I will take -8 I got from this graph to infinity.
-8 to infinity is your range. That is something you found out. And what was given to you? The codomain was given to you. What is the codomain for you? -8 to infinity.
-8 to infinity.
Now you map. Are they equal? Yes. If they are
Yes.
equal, then you can say it is on. Codomain will always be given to you. Don't worry about it.
So will it be always be equal, or
It may not
can
be
you
equal.
give another
Okay. So if I tell you this, -10.
Okay.
Or
So
let's say-
can you how to get the range? I am not getting the range part in the
one
graph.
way I told, I just explained you the set of y values. So how do you get range? Is nothing but the minimum value that your function takes to the maximum value the function takes. What is the minimum value this function was taking? -8. What is the maximum value this function was taking? Infinity. Clear? Clear, right?
Infinity.
Infinity. Because you see this is what the y values know. This keeps on increasing, isn't it?
Yes, yes.
This is how you get it.
Range is sir a minimum to maximum value of fx. And
of fx.
Then we have to compare that range to codomain.
Codomain, which is here. Okay. Thank you, sir.
You're welcome. So now I think we are done. Now we'll take up one more doubt and then we can wind our session. It's
So may I ask just a question regarding the smart
I have a doubt, sir. Sir,
Hello.
can you do
Sorry, what?
I just
SSC is somewhere here. Okay, just let me touch upon this SSC. You see, this one question was given to you, right? This mock thing. I can just discuss this. This is like very important. Practice this, okay? You see this, what you have been given is SSC formula. You have to know what does SSC formula tells you. Y minus f of x, the whole square. And you just have to sum them, right? Yi and f of xi, whatever. Yeah. So you see this. These are the set of x and y values will always be given to you, right? All you have to do is just find out f of x value. So how do you get this p of x value? Just substitute this x value into that p of x function, right? Just substitute the value and you get the expression. Then you write it here. And then what, you simplify them. Now after simplifying, now summation, it tells you summation, right? So after, it's sum of all these square terms. So you just write them up, you express it in this way, and then what you see, this is quadratic, right? Quadratic means what will have its minimum value? It will have minimum value at its vertex. Then all you have to do is find its vertex. You remember how I told you to find the vertex? Just get the vertex for that. So vertex means you just have to get the x coordinate of your vertex. That will be your k value. Once you get your k value, right, just substitute that k value into the main function, right? Expand this function and then get your y-intercept value. So y-intercept value is nothing but what? This h, the height. Okay. Okay, all clear?
Yes, sir. Sir, can I just ask one question about this March qualifier exam?
Yes, yes.
Actually, I attempted the Jan attempt for this qualifier, and I scored 70% total, but I didn't get the sufficient marks in maths. So when I asked the customer care support team, they said that best two scores of all subjects will be considered. So this time, if I just attempt maths for 4 hours and do not attempt any other subjects, will it be okay for the exam?
Yeah, it will be okay.
It will be okay? Okay.
Yeah. But I'm
You,
not sure
you
whether it
actually
is...
answered my question also that way.
Mine too.
I also, sir.
But yes, focus on completing all 4 because it will increase your end score, by the way.
Yeah. Thank you.
Yeah,
And
but
sir,
one more thing.
marks
Wait.
for,
I don't
sir?
know, like, if I answered your questions or not. Just give me a minute. I just want to clarify this. Okay.
Okay, sure, sir.
Just give me a minute. I'll just ask someone.
Yes.
If we qualify this time, we will start from week 1, na?
No, week 4. Week 5. Sorry,
week 5.
No, from this qualifier, you will get pushed to the May term. You won't be able to, you won't be able to continue through Jan term.
So we have to start from the very beginning.
No, I think week 4 will suffice. Week 4 or week 5. But that week 5 of the May term. So the portion might change.
Okay.
And also, can anyone tell me, is the Venn diagram question correctly solved in the mock solution? Is that the correct one?
I am having issues with mocks, these type of questions only, Venn diagram.
Okay, no, my doubt
Basically,
is
in last qualifier, last 2 questions, I didn't able to get it.
okay. My doubt is that correctly solved or? So let him come. Let's wait.
So if you are not going to attend, if something which I passed in January 30th, so the marks will be carry forward for this March. That's what it says.
Best of 2 will be considered. Best of 2 for each individual subject will be considered.
Okay, so you can combine and do a permutation combination of all subjects and then provide the actual results.
Which one I gave in January 30th, I got passed on that. Means I have to attempt it once again on March 30th.
Hello. I'm back here.
Yes, sir.
So I just confirmed. Actually, yes, you can just attempt math. So that is okay.
Okay,
Okay,
sir.
okay. Thank you, sir.
No, we don't have to attend.
Only the failed subjects, sir.
Sorry.
So everything you've covered in this lecture, only that amount of syllabus you're saying that it will come for the qualifiers, and everything you have not taken in this lecture will not.
No. It might come, but majorly it will be from this whatever.
Means
Okay.
doing these questions will help score very good
Yeah.
scores.
Yes.
Okay, sir.
Similar
Sir.
questions. Yes.
Sir.
Sir, I have one doubt. I have
Yes.
given
Now quickly we
the
can just end our
November
session. Just tell me. Yes.
qualifier and I was not qualified due to the match. Match, I was not passed in that. Then I applied for the January qualifier, but I was absent due to some reason. And now I have attempted for it. So will the marks of that November qualifier be carried forward to this, or I have to give for all the subjects?
So you wrote it in your November, your qualifier, is it?
Yeah, I wrote it in November qualifier and I was only disqualified in the mathematics portion due to 7 marks.
Okay. Are you eligible for writing this?
Yeah.
Then if you are eligible, then the best score will be taken.
Sir,
Yeah,
actually,
so
I asked the same doubt in the support team meeting, which was after the qualifier. They said that this is a special batch for only this qualifier exam for the
Yeah,
Jan.
that's what I was thinking. Like it's not for the others.
Yeah.
But if you have re-enrolled for this Jan batch and then you are writing it, then that becomes a different case.
Yes, because this is the first time they said that this is happening.
Right.
That
Right.
we
This
are
is
getting
first time,
to attempt
definitely.
for the
Yes.
same qualifier.
Yes.
Sir, I do have a doubt, sir. Vicky, sir, are you there?
Yeah.
So if I have qualified in all 3 subjects, I just didn't qualify in maths. So I
You can
have
just
to
ignore.
actually appear all the subjects in March as well.
See, that's up to you, because see, if you write this qualifier and let's say you pass, right, you get some score, that becomes your score for quiz 1. It's considered as quiz 1.
Okay.
But certainly you can attempt your quiz. So now when you will be joining your quiz 1, so you will be given again an opportunity to write your quiz.
Okay. If I'm not writing, then that marks will be carried forward for this.
Yes. If you're not writing your quiz 1, this same marks will
Excuse
be
me,
carried forward.
sir. Can you just go through last 2 questions of the qualifier paper? Previous
Last
one.
2 questions. Did you go
That
through the
Venn
solution?
diagram.
Did you go through the
Yeah, I
solution?
have seen, but I am not able to get it. I don't know. I get very hard with these Venn diagram type of things.
Okay, just
Set
tell me
1
quickly
or set 2, any set.
where is that Venn diagram?
Last 2 questions. I was giving set 1.
Okay, so this one.
Yeah. Sir.
Okay, tell me. Yes. What is your doubt?
Basically how are we arriving with these things? Here it is given 20, 25% and all these type of things. So how you are calculating this?
See, first when you want to draw this Venn diagram, you just took percentage and drew that, right? It just considered that these are just the percentage. Forget about this number. You have been asked just the percentage. Using the percentage, draw the Venn diagram. That is what we did.
Okay.
Once you get the percentage, then address the question. The first question is how many students like all the 3 subjects. The question is how many students like all the 3 subjects. So how many were there? 20%.
20% like
of what?
20%.
Of what? 1,000.
1,000.
Sorry, 1,000. So then you.
So basically, we have to start with the percentage, calculate the remaining.
Everything with the percentage, and at the end, you have to convert percentage
because
into some number.
20% is not given at all. 20% is not given at all.
So that is something you figure out using your Venn diagram.
Okay.
Right. So Venn diagram will be drawn only for percentage, and once the percentage thing comes out, what you do is then you simply substitute with the number. See, percentage.
And what I did was I got with the number and got confused with those percentages.
I knew. And see, other thing was this question I myself discussed in the revision session, and I was really touching upon this thing that you should actually stress on this point. And I was very much sure that people will also come and give percentage as the answer, and they come and they have given some 100 of you.
Okay. No, actually I scored pretty well with maths also. I only means there was some error with stats.
Okay, no problem. Then you can reattempt it and see.
Sir,
Yeah.
in mark
No,
also
I
there
am
is
trying to
some
increase
doubts.
my math score. That's why I asked.
Sure. You
Sir,
can
in
do
mark
it.
question I have some issues. The mark Venn diagram question, sir.
Which one?
Marks are in mark question.
Which one? Tell me. This one.
Yes, sir. The 10th question.
This one only. Oh,
No. 10th one. 10th. So the answer is coming 200 for me and it's 110. Is that right?
How are you getting 200?
So I have taken.
You have gone through this procedure.
Yes, sir. I have gone through, sir. But N of A is 120. They have also taken A plus B plus 30 also in consideration, sir, for N of A. Is that right?
Just see your calculation. There might be some calculation error.
Okay.
Check with your calculation, because this is something we did it and we also did it some kind of review.
Okay,
So
sir.
there was no error. So you just see with your calculation. It might go error there. Okay. So yes, we
Another
can.
question we all had in the meeting right now when you left was that many of us who didn't qualify, didn't attempt the rest of the weeks. I mean, week 6, week 7, week 8. So that won't affect our May term, right? Because we will be
You won't be writing
in
end
May
term. You won't be writing end term, no? This end term you won't be writing.
Okay, so it
You'll be
doesn't matter.
joining
We
next
have
batch,
to
yes.
attempt the week 5 and onwards from the May session.
Yes.
Okay.
Okay, that is something you'll have to do. All right, then. Thank you.
Sir, is practice assignment and graded assignment sufficient for this qualifier exam?
Parth, see, basically, what I'm trying to say is, whatever the material is given, that is more than enough, right? If you are going and reading from elsewhere, you will mess up with your qualifier. Just do whatever I have done in this today's live session and do your mock. Just do this much. This will also help you out. This will certainly help you out to solve the questions. Graded assignment and all these things for marks enhancement. Like if you want to score 90 plus, then you can do all that.
Yes, sir.
Right? Yeah. All right then. Thank you. Thank you all.
Thank you, sir. Thank you, sir. Thank you, sir. Thank you so much, sir.
Thank you, sir.
And see, one more thing, do not mess up with your MSQ questions. You know that, right? MSQ question, even if you choose a one wrong, incorrect option, you loses your entire marks.
Yes, sir.
So whatever you know, just select that. Okay.
Yeah, one question in my qualifier, it was an MSQ and just one option was correct. And in another one, all options were correct. So it does get confusing there.
That's why I only take those which I am pretty sure with.
To do that, okay, be wise enough to choose the right options. Do not feel like, okay, it's just a matter of if it is 4 marks and 4 options are given, you'll be like, oh, I'm losing 1 mark. With that 1 marks, you might lose 4 marks. Okay, so you have to be cautious that whatever you know, just select that. Okay, for MSQs, NET you have freedom. All right then. Thank you all, and
thank you, sir.
Well this time.
Thank you, sir.
I wish to see you all.
Sir, we are not having any English session also. English session, revision session.
I don't know.
It's the English.
I don't know about that.
Okay.
Thank you. Thank you.
Thank you all.
Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you.